Ich höre dich sehr gut.
Alles klar.
Funktioniert gut.
Dann darf ich einfach mal loslegen. Wir begrüßen die noch wenigen, die einfach bei uns sind, einmal online und natürlich hier auch on-site. Herzlich willkommen zu unserem Workshop. GRANITE EJEA, Anwendung von künstlicher Intelligenz, Fragestellungen von Datensouveränität, ja, und dann auch mal gespiegelt an der europäischen Sichtweise und auch an der japanischen. Ich nehme mir jetzt die Freiheit, auf Deutsch einfach zu reden, weil wenn ich mich hier so umschaue, sprechen alle Deutsch. Und dann machen wir einfach die Folien auf Englisch, bis unsere internationalen Gäste dazukommen. Dann machen wir einfach einen Soft-Switch. Mein Name ist René Reiners, ich arbeite am Fraunhofer Institut für angewandte Informationstechnik in St. Augustin bei Bonn. Bin hier umgeben von 2 Kollegen, die ich direkt anschaue hier bei mir. Von daher auch schönen Dank, dass ihr dabei seid, auch mit Beiträgen von uns. Dort leite ich die Abteilung Human-Centered Engineering und Design. Und das Motto des Instituts an sich ist erstmal zu sagen, wir stellen den Menschen in den Mittelpunkt und sagen, okay, bevor wir eine Lösung designen, müssen wir erstmal fragen, wie ticken die Leute? Was sind die Prozesse? Wie funktionieren die Stakeholder? Um dann Lösungen Schritt für Schritt inkrementell und iterativ zu erarbeiten. Und das schlägt sich quasi in allen Ebenen des Instituts nieder. Das werde ich nachher nochmal ein bisschen erläutern. Und die Abteilung, die ich jetzt hier repräsentieren darf, die macht das quasi als Kernkonzept mit sehr viel Methodenhintergrund und sehr viel Prototyping-Hintergrund. Und zusammen unterwegs bin ich mit Sabine Ganter-Richter, unsere seit mittlerweile mehr als 6-jährige Mitstreiterin beim Thema Deutschland, EU und Japan. Und da würde ich einfach mal das Wort an dich übergeben zum Vorstellen.
Ja, vielen Dank, lieber René. Ich freue mich, dass wir heute alle hier zusammengefunden haben, online und auch offline. Zu meiner Person, ich bin von Hause aus Übersetzerin. Ich habe an der Universität Bonn studiert und übersetze vorwiegend technische Texte und technische Dokumentationen aus den Sprachen Japanisch und Koreanisch ins Deutsche. Wir arbeiten seit 5, 6 Jahren zusammen, um auch an dem FIT das Japan-Netzwerk aufzubauen und Aktivitäten zu gestalten, sind da in Zusammenarbeit mit Partnern unterwegs. Ich glaube, ich habe einige Folien, zu denen wir später noch kommen, zu meiner Selbstvorstellung. Insofern möchte ich es gerne an dieser Stelle so belassen. Danke.
Prima. Wir haben das, wie man offensichtlich sieht, das Programm ein bisschen geändert, jetzt auch aus Zeitgründen. Wir haben noch ein paar Grußworte natürlich von dem Vorsitzenden Dietrich Albert von der Universität Graz, von der EJEA. Das ist die European Japan Experts Association, also auch ein loses Netzwerk, aber in Vereinsstruktur, was sich eben mit Japan-Kontakten auseinandersetzt im akademischen Bereich. Es gibt eine jährliche Konferenz dazu, die auch wechselnd unterwegs ist. Die ist teilweise in Japan, in Europa. Bei uns am FIT war die schon 2-mal jetzt. Auch Corona geschuldet, haben wir es halt dann online oder auch hybrid angeboten. Das ist die EJEA, wo wir auch Mitglied sind, als FIT dabei. Und dann gibt es noch diverse andere Verbände, die eben uns auch als Multiplikatoren und Netzwerke einfach dienen. Und die Grußworte schieben wir einfach ein bisschen. Es gibt, jetzt aus Zeitgründen, legen wir das einfach nach hinten. Dann hatte ich geplant, Ihnen oder euch, wir sind ja eigentlich beim Du, wenn ich das hier richtig gesehen habe, auch mal ganz kurz ein paar Worte zu GRANITE zu sagen. Was soll das Ganze eigentlich? Was ist das für ein Projekt? Ne? The Solid Network of Your Future of Work. Man merkt schon, das ist ein bisschen reißerisch, was da drunter steht. Das Ganze kommt von einer Forschungsmarketing-Kampagne von BMBF aufgesetzt. 2018 war dann Call, 2019 begannen die Projekte. Das war die Initiative The Future of Work. Wie sollen wir arbeiten? Was kommt alles hinzu? Da waren dann noch die Topics, meinetwegen AR, VR kommt vielleicht auf uns zu, Blockchain waren die Themen. Ich sagte schon, damals hieß das alles irgendwie KI. Eigentlich meinten viele Machine Learning oder viele meinten irgendwie Decision Support mit Algorithmik. Nicht das, was wir heute unter KI größtenteils verstehen. Viele denken halt an Gen AI, obwohl das ja auch mittlerweile für mich ein Reizwort ist, weil jeder fragt, hör mal, ihr bei Fraunhofer macht ihr was mit KI? Die Antwort ist ja, in jedem Projekt, weil wir haben Computer. Ne? Das ist mittlerweile so breit gefasst, dass das so in die Richtung auch dann schlägt. Da waren aber auch die Themen, und die sind es immer noch, eben neben Industrie 4.0, Society 5.0, also auch die alternde Gesellschaft, sowohl in Deutschland als auch in Japan trifft uns dieses Thema, eben zu immer weniger junge sozusagen BerufseinsteigerInnen, die noch dazukommen, und eben die alternde Gesellschaft. Wie kann Technologie hier vielleicht helfen, dass wir auch da Menschen befähigen, auch im höheren Alter weiter zu arbeiten, weil sie es wollen, nicht weil sie es müssen, und auch dementsprechend auch Ersatz zu schaffen durch Technologie. Wenn zu wenig Arbeit da ist oder Arbeitskraft da ist, müssen wir halt Ersatz sozusagen finden. Wie bekommen wir das mit Themen in der Gesellschaft überhaupt zusammen? Diese Initiative sagte, wir fördern 10 Projekte in den USA, in Frankreich und in Japan. Und da wir uns gerade frisch kannten, haben wir gesagt, prima, dann schlagen wir zu, wir machen die Marketingkampagne Japan. Es gab relativ kleines Geld für 2 Jahre, im Wesentlichen Reisegeld. Also immer zu sagen, wir haben Netzwerke, wir erschließen Netzwerke und wir bringen die Marke Deutschland sozusagen wieder mal in den Mittelstand, in die Unternehmen, aber auch in die Akademie. Dann braucht man eben den Namen GRANITE und das ist natürlich ganz einfach zu merken, das muss ich immer mit ablesen. Das heißt eben German Research Ambassadors Network for Industrial Technology Endeavors. Das macht man, wenn man eine Flasche Wein getrunken hat, nach dem Antrag. Dann baut man sich so ein Akronym nochmal zusammen. Und diese Marke GRANITE haben wir tatsächlich bis heute vertreten. Das ist also ein Netzwerkgedanke dahinter. Und sobald wir mit jemandem in Kontakt treten, Deutschland, Europa und Japan, sagen wir, werdet doch Mitglied. Das ist also wirklich ein lockerer Netzwerkverband. Und da kann auch jeder einfach beitreten, ohne Beiträge, ohne Vereinsstrukturen. Das ist einfach nur, wenn ihr jemanden braucht, der sich mit Japan auskennt, oder wenn ihr gerade Japaner seid und ihr müsst jemanden aus Deutschland und Europa haben, fragt doch einfach mal. Wir können da doch auch weiterhelfen. Wie kam das Ganze zustande? Ich habe schon kurz angefangen, 2019 Antragstellung. Dann hatten wir ja noch die Möglichkeit, im Oktober 19 eine zweiwöchige Reise zu machen. Wir sind vornehmlich in den Präfekturen Tokio unterwegs, Kagawa und Nagano, alle unterschiedlich geprägt, aber auch ein bisschen kleiner geprägt, ein bisschen ruhiger. Sabine sagt immer so nett, das sind die Hochschulen in der zweiten Reihe, die eben nicht so mit Glanz und Glamour unterwegs sind, die aber durchaus sehr, sehr viel zu bieten haben, aber auch überschaubare Prozessketten haben, sodass sie sich auch agil und relativ schnell bewegen können an der ganzen Sache. Ihr seht hier schon, da waren Besuche beim Gouverneur der Präfektur dabei, es waren Universitätsbesuche dabei und das hat sich immer fortgezogen. Und dann kam natürlich Corona. Also wir hatten 3 Tickets geplant, 2020, alles kommt zum Erliegen und zum Glück gab es diese Präsenzveranstaltungen zuvor, sodass die Kontakte halten konnten. Das war ganz wichtig, weil man eben so online lernt man schwer Leute kennen, vor allem wenn die Kultur auch noch leicht unterschiedlich ist und noch eine Sprachbarriere dazukommt. Aber wir haben die Aktivitäten beibehalten. In 2023 durften wir wieder Leute hin und her schicken. Da war eine Gastwissenschaftlerin von uns dabei für 3 Monate. Und so kam es, dass auch die japanischen Professoren immer wieder zu uns kamen. Hier im Bild nochmal Professor Tanaka. Das ist der Mann links. Ne? Das Bärchen ist jemand anderes. Das ist der Arukuma. Das ist das Maskottchen von der Präfektur Nagano, das Apfelmännchen. Und die waren immer regelmäßig bei uns. Und das gipfelte darin, dass wir ein Satellite Office eröffnet haben. Also die Shinshu-Universität in Nagano sagt immer, wir müssen was Repräsentatives machen. Also in Japan noch fast mehr wert als bei uns. Also immer, man muss ein hochpolitisches Event machen, man muss in der Presse sein, man muss sagen, wir bemühen uns um forscherischen Austausch. Wir haben noch keine Zeile Forschung geschrieben, aber wir haben quasi den Austausch und diese ganzen Konstrukte etabliert im Rahmen dieser Projekte. Und das gipfelte halt dann in diesem Satellite Office eröffnet. Das ist natürlich ein Büro bei uns am FIT. Natürlich dementsprechend auch Dekorationen, Japan-Fahnen, Türschild haben wir auch dabei, was im Endeffekt sagt, wir untermauern diese Kooperation, die wir mit der Universität haben und mit der Präfektur Nagano. Die haben eine Joint Declaration, auch wieder sehr politisch unterzeichnet. Und dementsprechend haben wir jetzt quasi eine Grundlage für Staff Exchange, für Besuche, für gemeinsame Antragstellungen, dass man da sozusagen diese, ja, soll man sagen, die organisatorischen Hürden sofort nehmen kann. Das passiert jetzt auch wieder. In 2 Wochen geht es wieder nach Japan, auch für uns. Wir sind wieder unterwegs. Eine Delegation aus Bonn ist da. Dann eröffnen wir in Nagano ein Satellite Office von uns. Das ist alles repräsentativ gedacht, damit man einfach einen Ankerpunkt in den beiden Ländern hat. Auch mal so als die typische Folie, ne, mit wen kennt man denn so? Hier, wenn man da mal in Ruhe drauf guckt, sind viele Universitäten aus Japan vertreten. Wir haben aber auch den Forschungscampus Mittelhessen mit an Bord, wo auch fleißig genetzwerkt wird. Da war ein Parallelprojekt bei uns. Und dementsprechend haben wir auch den deutsch-japanischen Wirtschaftskreis in Düsseldorf als größte Community hier in Deutschland und diverse andere Player, auch aus der Industrie. Das soll einfach nur zeigen, man kommt locker rein in dieses Netzwerk und wir kennen immer einen, der einen kennt, der weiterhilft. Ja? Gleichzeitig wir auch als Fraunhofer natürlich mit recht vielen Instituten im Hintergrund. Wir haben noch einen Gast. Ich darf mal guten Morgen sagen. Sprechen Sie Deutsch oder lieber Englisch? Then we will switch to English because up to now we didn't have, we only had German participants. But now we will directly switch back. So we had an announcement. No worries. I'm just introducing the GRANITE project, what it's all about. So welcome. Okay. What kind of applications do we cover? So if you have a look, it's a broad variety. Predominantly, it's the digital transformation for SMEs. Always a question like we have all those new technologies, these new approaches. How, as an SME, should we start doing that? Where do we start? What kinds of technologies do we really need? And who on earth should do that in my company? We don't have the people for it. So it's a lot of sorting, giving orientation. Circular economy, the next big thing in Europe. We have all those CSRD reporting coming next year for from a certain amount of employees in the company. You have to create those sustainability reports. This the supply chain management and also the documentation of your supply chains plays a major role. How to get all that data, how to put more intelligence in my processes that I get this data out. Of course, data spaces is a big topic. I will not go into detail today on this. This is an own presentation also today. Usable privacy, we have a lot of devices and smart devices in our private households. We have that in our working environments. What kind of information is collected? Where did I agree? What am I blindly using and don't know what's happening in the background? So making that transparent and understandable is also a big topic, together with human AI teaming. I was a bit complaining about AI in the beginning, but now we do have a lot of artificial intelligence support. Once we understand it and know how to use it, and we know about the limits, we must find ways how do we integrate them into our work in the private life, because they are helping. I mean, they can save a lot of time and they can really support in certain tasks that are repetitive, or we just need some new, let's say, outcomes of a certain prompt, whatever. How do we do that? Human AI teaming is a keyword. So we are not excluding the human on that. And last but not least, there was a trend in 2019 about immersive environments. It's still ongoing. There are projects running, but it's not so prominent anymore because it was declining after we had this AI initiative, so to say, starting 2 years ago. But nevertheless, we have a look at these things in case that we have something like extended reality or even virtual reality, where you completely are able to lose your identity. Since you have avatars, you can have nicknames, you can do whatever you want. What happens with your mind? So from the psychological perspective, we are also tackling this topic. At FIT, we have a group that are really doing the hardware and the technologies, but here in this project is more like understanding, explaining, exploring. We can see that from those small arrows, they are crossing that. So we are doing that with methods. So first of all, understanding, it's innovation engineering, a lot of user-centered design, a lot of user-centered computing. As I said, understanding, having workshops, building cheap prototypes that can be thrown away. That's the idea behind innovation engineering. Once we have a solution, we must make them usable. Not nice looking, but usable. That's the difference. So really that you understand what this thing is about, what the next steps are. So we could, for example, do a small usability test of this web platform. So it will fail because people don't know where to click. So we just had that this morning. And then you can make it nice and you can create the experience around it. And the other ones, I already mentioned that from the paper and cheap prototyping, we can also do digital prototyping. Is it possible to use this and that? Yes, it is possible, but it's large at the moment. It's too big scale, but miniaturization can be done later on. So it's no problem. Or we can use them in living labs environments. It's not that we put the user in the lab and monitor, but that we have lab environments in a private household, lab environments in the company where we're just using the new technologies and try them out, and we accompany them from a research perspective. So our job, you can see always we have all those new technologies. We must get the users from, oh my God, to here to succeed. And how do we do that? So just repeating that. First, we need to understand what are who is doing the work. Who are those people? Are those firefighters? Are those people working in a clinic? Are they working in a factory, in an office, whatever? Who is there? What is their background? From IT to professional skills, depending where you are. It's a lot of getting to know, a lot of interviewing, a lot of, let's say, monitoring, watching, and learning. It's very participatory, this kind of design. It's really a lot of fun because you get into environments you have never seen before. Sometimes a bit creepy, I can tell you stories later on, but also very adventurous environments, like in policeman training or in firefighters training. So we can also participate and watch up to a certain degree, of course. Where do they work? What are the surroundings? What's the so-called the usage context, the user context? What are they doing? What is the process? Why on earth are they doing that? Or maybe do they have a workaround? So there's also a procedure book they need to follow officially. But there are a lot of things, we all know that from our own work, where you just do something, but it's a workaround that helps you remembering things or making things easier or even better. And that's all what we need to understand. And this is a slide you will always find on our website, so to say. We normally or formally use the term of user-centered design or design, implement, analyze cycle. Nowadays, everything is design thinking. So we have a design thinking factory, and it's not a one-way ticket that we start with a challenge, go through a problem space into the solution space. But once we have an idea after the evaluation, it can go the way back and we improve our solution or our prototype until we have the innovation engineered in a way that it's usable and accepted by the users. couple of words on Fraunhofer. I mean, I need to skip that a bit because there are many Fraunhofer people in here. Just to mention, we are here on this nice campus. Normally, I just show the castle. That's where I'm working. That's the nice place. But to be honest, that's something I look on too when I look out of my window. So we are in this nice building with a satellite dish on top that are not functional anymore, but you can directly spot us from a plane or wherever. That's our campus. In total, we have 3 institutes with different topics, FIT for Applied Information Technology. And on the small map of Germany, you can also see we are well connected in the Bonn-Aachen area and also with the other institutes around there. And we have 2 branches in Augsburg and in Bayreuth. That's also a branch of the institute, predominantly working on also computer science, but from an economic perspective. This slide is later on maybe for your interest. Just wanted to mention that we have a lot of core competencies, human-centered engineering and design, very method-driven, prototyping-driven. We have a neighboring department. Once we are done with digital prototyping, we need to get the data and do something with the data. And that's, of course, the neighbor department, data science and AI. When it comes to immersive environments, we have cooperation systems. They have this thing with extended reality settings, but also with classical 2D collaboration spaces. These are the topics that are always, so to say, connected to each other, and information systems engineering in the branch Augsburg and Bayreuth. If you need more information on that, there's a lot of things to say about this institute. Also that we have an education center, please come back to me, and I will go into details with you. So, and now I was saying a lot of things about the GRANITE network and that we know a lot of people. So the core team was on the one hand side an academic partner, so it was FIT. But I mean, we are on this hill. And of course, we have this challenge of getting to know people. And we're doing our best. So we even get outside, we have those meetings, we have workshops like that. But in order to get into these communities, especially in Japan, you need experts who are really, since long term in the field with a lot of experience. And that's where Sabine comes in with her company, Network for Science. And I think it's best if you introduce that by yourself.
Thank you very much. So my company, Network for Science, was established in 2010 already. But before, I have been working at a Japanese funding agency who is located in Bonn with a representative office. And this funding agency is called JSPS, Japan Society for the Promotion of Science. And we will later on have also a presentation of their fellowship programs in case you are interested in doing research in Japan. There are some partners available who will support you. So I'm working for more than 25 years now together with Japanese partners and colleagues, and also my main professional network is located in Japan, not here in Germany. So I'm well connected to researchers from all fields in Japan at Japanese research institutes and universities, also to the ministries in Japan and organizations. And when we joined forces 6 years ago, we also addressed more companies, local SME companies in the regions René already mentioned, in Nagano Prefecture and Kagawa Prefecture, and especially in one part of Tokyo. I will come back to that later. So my services I offer here, we wrote it in a long list. Well, together in discussion with René and also with my partners in Japan, we try to identify topics and also partners who would be a perfect match for future collaboration. And by doing so, we initiate projects, joint projects, and of course, to realize these projects and the collaboration, we organize visits to Japan, and also Japanese delegations coming to Germany, which we show around in our institutes here. And also when we go to Japan, of course, we visit institutes and companies and talk to organization and networks initiatives. Maybe that's enough. I don't know.
One more, if you just go on the right side.
Yes, the right one. Okay, so I listed up a couple of related networks that we are in close contact. Maybe first of all, I should mention the EJEA. That's an abbreviation for the European Japan Experts Association, a European network of researchers that spent some time in Japan, but almost 25 years ago or 30 years ago. That was a fellowship program, and I will later on explain more about the EJEA network, since EJEA is one of the co-organizers of this workshop today. The second one is also an alumni network from former JSPS fellows, mainly German researchers who spent research stay in Japan by fellowship programs offered by JSPS. Then we have on the cultural level so-called German-Japanese societies, Deutsch-Japanische Gesellschaft Bonn in our case, and also the Japanese-German Society in Kagawa Prefecture. These two associations, they have a partnership already for 30 years now, and this is the occasion why we are going to visit Japan in the middle of October, since we celebrate 30th anniversary of this partnership. The DJW in Düsseldorf is in German, Deutsch-Japanischer Wirtschaftskreis in Düsseldorf. English name is German-Japanese Business Association, with about 1,600 members, companies located mainly in Germany, but more and more also located in Japan. They also have an office in Tokyo since a couple of years, and their events really spreading all over Germany, and also in Japan they are quite active. JETRO and JIHK, I take the German pronunciation. JETRO is the Japan External Trade Organization, so to say, Chamber of Commerce overseas to promote external trade from the Japanese perspective. JETRO offices all over the world, of course also in Düsseldorf located, and the Japanese Chamber of Commerce in Düsseldorf, Japanische Industrie- und Handelskammer zu Düsseldorf, also covering about I think 300 only Japanese companies who have a representative office in Germany or in Düsseldorf area. So also a very strong network when it comes to the company and industry side. We mentioned already our three partner regions in Japan. In Nagano Prefecture, I should mention the IT Valley initiative. There are quite a huge startup scene dealing with software applications and software technologies. And all these software is developed by Nagano startups for local SMEs to support them on their digital transformation. We have NICE, that's also a Nagano Prefecture institution that is promoting and encouraging industrial collaboration. Then we have the Shinshu University, headquartered in Nagano City. Shinshu is the former name of Nagano Prefecture. This is why we have it here. Then we have the Association of SUWAMO. This is an abbreviation also. The area is Suwa, located in the southern part of Nagano Prefecture. And around this Suwa area, there are many manufacturing companies. And manufacturing or making things, the Japanese word for that is monozukuri. You might have heard of that if you deal with Japan and economy-related issues and topics. Monozukuri is the word, producing, making, manufacturing things is the meaning, and Suwamo means Suwa Monozukuri Association. Then we have the DTF study group. Desktop Factory is the longer word for this study group. That's also an association of about 100 companies, also in Suva area, that produce prototyping machines on a small scale that you can put on the desk, and you can run your tests and can make use of them. So that's quite a research-related study group of companies. In Tokyo, we are mainly dealing with our partners in the city Ota. That's a part of Tokyo close to Haneda Airport, where also the Tokyo Institute of Technology is having its headquarters, its main campus. And in this Otaku, we are cooperating with the Office for Economic and Industrial Support. In Germany, we call such institution Wirtschaftsförderung, and they cover about 400 manufacturing companies in this special area in Ota City. We have the German Chamber of Commerce with a representative office in Tokyo, and also our federal state NRW is represented by the NRW Global Business Office to support Japanese companies on their way to our NRW region. In Kagawa Prefecture, this is more in the southern part, eastern part on Shikoku Island. Of course, also with Kagawa University, our strong partner. We have many local companies also connected to Kagawa University, and by that we can get access also to the local companies there. And another partner, which is quite interesting, is the city administration of Takamatsu City. So these are our networks, and via these networks, we can also address further partners. Then I would like to come back to the European Japan Experts Association, the EJEA, and the annual conference. Renee already mentioned that. I would like to announce and invite you all to our next hybrid conference in November 5 to 7, which is hosted by the Linköping University. And the title of this conference is Future Knowledge and Competence for AI-Driven Innovation in Europe and Japan. And I have mentioned the link here. So the call for contributions is still open. We are planning to have a couple of workshops, and you can also contribute with a poster. Please take a look at the site, and in case of any further question, contact me directly. I will give you more information. So far from my side, and I hand over to René again.
Yeah, quickly, may I have the magic device here? Thank you very much. So in case you're interested, please drop me an email. I can also forward you the slides. Of course, you as participants, I don't have a contact data for you. Just in short, your takeaway message. What's your benefit of dealing with us, so to say? You have an access to Europe's largest organization for applied research located in Germany, which is Fraunhofer. It's really advertisement, I know, but we are 76 institutes in many, many branches. So whenever we get a question IT related, we mostly can handle those things, or we forward that to our colleagues from this alliance we have, from the ICT Alliance, or we forward to other departments, be it material science, be it medicine, chemical processes, etc., etc. But first of all, you have somebody to ask, because sometimes I think a big, let's say, institution like Fraunhofer, sometimes it's hard to handle to start somewhere if you're looking for contact and for help. Then you have, of course, access to a large network of industry partners. So even Fraunhofer or now GRANITE and Sabine, we can act as connectors, so to say. We can do surveys. We know we multiplying agencies. We just mentioned the JETRO, JIHK, the DJW, etc. There's a lot there. These are networks with more than 1,000 participants, and in the other networks even more. We can just ask a question inside and forward you to those people. In this case, we have a collaboration with many players, or we just forward. Why not? I mean, that's also a way of doing networking. Then we have access to German and Japanese universities, and also to the companies and also to the research institutions. So whenever you as a researcher are looking for somebody who's hosting you, just give us a sign. We can get you in touch with those people. They are very, very interested in hosting. There are programs from the DAAD, from the JSPS. Maybe you have an internal one in your institution, but you need a host. Just ask us. Asking doesn't cost anything. We can forward you. And again, we're doing the networking part. We have external inquiries by now. We have the Ritsumeikan University from Kyoto. We have some universities from Hiroshima. They know us already. They are coming. Maybe spend a visit, maybe exchange about our topics. So it's all a very, as I said, loosely coupled network, very easy to address. Yes, the speciality, I think I talked about it enough right now. So we can do this human-centered engineering approach. We analyze, invent, prototype, and implement. And of course, we do a feasibility and applicability checks before you really design a technical, fully fledged solution. So don't hesitate, become a member, just contact us. It's for free. It's just for the sake of getting into collaboration for future projects and direct collaboration. With these words, thank you for listening here. And also, if you're more interested, please drop us a line. It's no problem. We're happy to help and have you on board. And this is all the frame where these activities are being, let's say, collected. I would quickly like to guide us through the day. So we have lost a bit of time due to technical issues, but also to the queues in the beginning. So I see people have made it now from the entrance to this workshop. I'm very happy to see that. I would not like to change the agenda anymore. So I would directly hand over after my small presentation of the agenda to Arjan Hansen-Amper from the ITA from Aachen University. After that, we have a short introduction from the JSPS program. So these are, the colleague is giving you ways where you can get money or funding for a stay in Japan, for example. So these are the, how to say, these are the mechanisms to make an exchange work. And so the colleague will also introduce that after the next talk. And then we start with our presentations. After a coffee break, for half an hour, we will go through all the presentations we have. It may happen that we need to shift this order again, depending on people arriving or maybe coming later. So there's no problem. And you can see we have a lunch break, which is quite long, 90 minutes, which is very good since we are talking about networking. So we have lots of time to talk and maybe ask back. So we really appreciate that. And then we have the third session going to 15:30 German time and ending with a networking coffee. Again, if we go to the coffee break, we are still available, and maybe you among each other or with us, we're happy to do the exchange there. You see, it's a very tight program. I have seen or I've gotten a lot and very nice contributions with many slides at some point. So please try to stay within 20 minutes. I would like to offer some space for discussion, or we shift that to the coffee breaks, but we really need to run through that program to have the chance that every speaker has really the same amount of time, because I'm a bit afraid that after the coffee break at 15:30, nobody will come back. So people are going to the Sektkellerei, I think. They are really going to the entrance doors for the social event. Okay, any questions so far? Hope nobody fell asleep directly after arriving, so I would like to pass over to Arjan. You are still there?
Yes, I'm still here. But thank you very much.
Excuse me, I need to switch a couple of technical things. So I need to disable this screen sharing and take the other one. Just get yourself ready. Just a moment, please. Because you still don't have this button for sharing, right?
I still don't have the button, no.
No, it was not included in your ticket.
Unfortunately not.
Okay, but we will handle this. So.
But I see that we've got a few guests, which is nice.
Yeah, it's filling a bit. That's nice.
Well, maybe I can already start with the introduction or with the introductory words, because as I would have stated anyway before I actually get started, there are two things that I want to get out of the way first. The first is I probably have enough material for 20 to 30 minutes of monologues, but I would be much happier, actually, to have a dialogue with you. So if in the course of my talk there's anything to ask, to add, or if you just want to, for example, challenge any of my positions, please feel free to do so. I heard from René, he's willing to run around with his microphone. And those of you who are with me online, just butt in whenever you want to say anything. And the second thing is, well, this presentation that will pop up on the screen any minute now is split two ways. At first, I want to provide kind of like a broader overview on how the social sciences or sociology of technology perceive innovations such as AI. And afterwards, I would like to actually show you how we, as sociologists of technology, put these theoretical backgrounds into practice by introducing you to a work scientific project. And I will probably also be able to show you that there are actually many parallels and connections between us and Fraunhofer FIT, as I've just gathered from René's slides earlier. Okay, great. As I can see the slides, I guess you can too. So
yes, we do. So sorry, I was muted. So you're back on track, and you can just command me to switch forward to your slides.
Okay, great. So, like I said, what I want to do is give you this broad perspective on how sociology of technology deals with technologies such as Gen AI. But when it comes to the main title of this presentation, do algorithms dream of social impact? At least in my mind, it is terrible. So you might ask the question, how did they come up with it? Now, I'm willing to bet that some of you already heard presentations and talks before in which the speaker at some point says that ChatGPT, Claude AI, or any other Gen AI assistant has been used. Unfortunately, I am no exception, because I was really trying to come up with a catchy title for this presentation, and I just had this. Next slide, please. Yes, and I had this book, or the title of this book, as inspiration: Do Androids Dream of Electric Sheep? In case you are not familiar with the book, it is the basis for the monumental movies Blade Runner and Blade Runner 2049. And so with this title in mind, I consulted the AI assistant of my university, RWTH GPT. Next slide, please. Yes, and I gave both models offered by my university the task to find a catchy title and added the title of the aforementioned novel as inspiration. Next slide. And as you can see, both models generated the same title under number 1 by taking over the formula, does X dream about Y? Now, while I think that most of the other titles are actually better than the first one, almost all of them assume that algorithms and AI can be actors, which then again leads me to the first question I want to discuss with you. Is AI actually capable of social action or action in general? Next slide, please. Max Weber, who was one of the founding fathers of sociology in Germany, distinguished between observable behavior, which can be intentional or unintentional, and action. And action is always intentional. For example, I hope you can see me, if I scratch my chin just as reflex because of an itch, for example, it is merely behavior. If I scratch my chin because, for example, I actively want to remove some food sticking to my beard, it is action. And if scratching my chin is oriented towards other social actors, for example, towards you, as I've just done now, to show you, to make a point, it is social action. And with these examples in mind, you might probably now understand our struggles as sociologists of technology when it comes to categorizing technology. Technology, at least in Weber's time, was not nearly as sophisticated as it is today, so it wasn't actually in its focus. Next slide, please. More recent sociologists of technology, such as GRANITE, take a more differentiated stance on action, because of these technological advancements. So they see action as gradual, and therefore technology is included in this notion. However, as you can see in this table, not all technologies have the same capacity for action. They are categorized in a range from passive technologies like a hammer to highly advanced transactive systems. When it comes to these transactive systems, at least until 2003, GRANITE assumed that only humans had the ability to act differently, as he puts it. I guess a different way to word this would be to have the ability to be unpredictable. So now we could ask, is this still the case today? Next slide, please. So headlines like these, like the one on this slide and on the next. Next slide, please. Yes. And also OpenAI's or ChatGPT's tweets certainly foster the impression that, well, LLMs, large language models, might have reached the transactive stage, since these systems clearly have the capacity to surprise us. Next slide, please. So that said, it is also GRANITE who actually shows us that categorizing the isolated actions of technologies probably isn't all too important. After all, and I hopefully will make this clear, many operations do not consist of isolated human or technological actions. Instead, GRANITE introduces the concept of distributed action and distributed agency, which is in line with terms like hybrid socio-technical system. Now, my favorite example to bring across what is meant with these hybrid socio-technical systems and with distributed action is driving a car with an internal combustion engine, because many people still have the impression that as they press the pedal, they directly control engine output in terms of power delivered to the driven wheels. But nowadays, we no longer have this direct cable connection to a carburetor with a fixed air-fuel ratio. We have drive-by-wire systems, which means that our inputs create electronic signals which are interpreted by an engine control unit in line with the speed we are traveling, the gear we are in, the state of the engine in terms of RPM, temperatures, and other variables. Of course, there are environmental variables such as air temperature, ambient pressure, and others. Next slide, please. And while our car is in motion, there are even additional data that are provided, for example, by an IMU, acceleration, we have wheel speed sensors, we have a steering angle sensor, and others. And they are all used to further control what the car does when you give the signal to accelerate. Depending on the perceived driving stability, the car will actually not accelerate, but instead reduce engine output and apply certain brakes. And the first iterations of this technology, you call it ESP or DC in certain cars. Well, these technologies, they operated quite harshly. So the driver got the impression or the feeling that the car actually interfered with what they were trying to do. Next slide, please. But nowadays, these newer systems are so much more advanced and subtle. For example, they even allow for a certain slip angle, making the driver feel like they actually pulled off a drift, for example. So what we sociologists of technology then ask is, well, who is performing the action? Is it actually the human driver and his capabilities, or is it technology with all of the sensory data? Well, what we actually do is we say that this action is distributed across the different subsystems of a socio-technical system. Next slide, please. Okay, so we can assume that AI can act autonomously, at least to a certain degree, and that it forms hybrid socio-technical systems with humans, in which both subsystems work together to form joint actions. Now, does that mean that these joint actions become more objective thanks to AI? Different studies and theories from sociology of technology, science and technology studies, and others say no, since every technology, including generative AI, is socially constructed. So what does this mean? This means, for example, that what Gen AI systems should be and what they become is dependent on the social groups of the developers, for example, as well as the users and other stakeholders. So if all of ChatGPT's developers are similar to Sam Altman concerning age, gender, social upbringing, and so on, this certainly shapes the definition of goals and use cases from the from the developer side. At the same time, ChatGPT is formed by its users and also other stakeholders, such as policymakers. For example, in the EU, we have the AI Act. Next slide, please. I myself, as an innovation researcher and also network researcher, have created a network-based innovation model. Next slide. And with the help of this model, I don't know what's happened there. Somehow, half of it is not appearing on my screen.
Yeah,
but
for some reason, it seems to be a bit distracted. Sorry.
Okay. Well, with help of this innovation model, I've shown how different innovation phase specific social networks and also different interests in and between these networks and innovation phases shape the way socio-technical systems are perceived and accepted. And with help of this model, I could predict whether these technologies will be successful and sustainable. However, AI is a special case because it is, of course, dependent on data, which in itself is subjective, as you will all know under the keyword bias. Next slide, please. And to exemplify this, I actually, on Friday, used my local installation of Stable Diffusion to generate images of two lovers kissing. And I used exactly this prompt, two lovers kissing, over and over again with several models. Next slide, please. Yes, so the first slide was pictures that were generated with the deliberates model. This one, or these pictures are generated with help of the model Juggernaut XL. And next slide, please. These are pictures generated with the model's realistic vision. I also used the base model version 1.5 and other models. And these are just some of the pictures that were generated, but you can already see clear patterns in these models and also between the models, right? So next slide, please. So after dozens of repetitions, I could only actually generate a handful of pictures that were not heteronormative. And all of these pictures that were not heteronormative show a kiss between two women. Next slide, please. So, in this case, Gen AI teaches us that two kissing lovers means that both of them, that they are man and women, and both of them are young, Caucasian, and overall beautiful. And hereby, these models reproduce and reinforce all kinds of stereotypes, as well as, amongst others, cultural and ethnical hegemony. This then again leads to another techno-sociological field of study, namely technology assessment, that is figuring out the social and societal effects and impacts of Gen AI. Next slide, please. Here I just listed some of the many questions that can be, and in many cases are, actually discussed. So, for example, how does Gen AI change the way we perceive the world? How does GenAI change the way humans interact with each other? Will GenAI further marginalize certain minorities, cultures, and ethnicities? And I kind of showed you an example of that with with my prompts and the pictures that were generated. Will GenAI devalue certain professions or aspects of these professions? We'll come back to this later when it's we talk about work systems. And will GenAI increase or decrease carbon emissions, for example, when it comes to the when it comes to sustainability? Okay, next slide, please. Okay, so after presenting some of the theoretical questions that keep us up at night, I want to now show you how we actually tackle them in practice. And for this, I will present you, a bit of my project, Wirksam Competence Center, and I hope to show you that there are quite a few overlaps between us and also the GRANITE application domains, as we've heard from René. For example, usability, digital prototyping, and also using living labs. But maybe before I continue, are there questions so far? Or anything you would like to add?
Looking around. Any questions or comments? Everybody looks very satisfied, Arjan.
Great. Okay, then I will continue with the next slide. Okay, so I mentioned this project, Wirksam Competence Center. So Wirksam Competence Center is a fairly large project.
Hello?
Yes.
Yeah, I had a comment or a question. So basically with the, you showed the different pictures and how they are generated, right? And basically for me, this is like like expected behavior, right? Because if you look at the training data somehow, right? This is like not something that should be something that is a surprise. And like it's not that these AI models are some sort of magical bullet or something, right? But they just kind of analyze patterns, right? And repeat what they have seen. It's not that. And so this is not something that surprises me in a way. And should be communicated that these AI systems have kind of these limits, right? And that they shouldn't be thought of as, also you said that kind of the bias. And it's kind of important to understand the bias in the training data in a way. And then you kind of can predict what these AI models are kind of capable of.
Yes, thank you for the comment. Because this is something I have repeatedly thought about. And you said something that is interesting. It strikes me, at least, as interesting, which is, well, it is to be expected. Now, I would like to answer with the question, so why is it to be expected? Is it just statistics, meaning that we have far more white people on the world, on our planet, and far more heterosexual people? So it is to be expected to see two white, young, beautiful people kissing than, for example, Asian people, Black people. Is this really the case? Or is the data in itself already biased by, for example, cultural norms, by, like I said, cultural hegemony, because the Western world actually dictates what is deemed beautiful, desirable, and so on?
Yeah, thank you. I'd also like to comment on that. So, of course, I think we do see that there is a certain bias in our media, in our output for the past 100 years. In movies, in any kind of media, we see it was usually Western dominated for many years, many cases, particularly what we consume, but we also, of course, brought this to other places. So I think right now, if we use these kind of data as training data for our AI models and generate new data based on these, and as you showed us, we produce a biased data, some sorts. It's biased because of the training data is biased. I think we have to be careful that we do not flood like the internet with even more data and make it even more difficult to get this bias out of what we consume daily. So I think that's a really important point you made. Yeah, thank you.
If you like, we can start a business on that, call that a tool which is called the stereotype detector.
Yeah, I like this. I like the name and I like the idea.
So if you're like, I'm a professor here in Wiesbaden, and then just contact me and we start that business on the stereotype.
I'll keep you in mind. I will show you my contact data later on the last slide, or maybe you just contact René and yeah, hit me up.
Yeah, if I may do one final comment. So, respect to your question, like like the training data doesn't have to reflect the truth of reality, right? And like whoever curates, and you said like whoever constructs these models, right? Like in Silicon Valley, right? Like they have kind of the power. And for example, for ChatGPT or whatever, we don't even know the kind of training data, right? So these is basically impossible kind of to predict then in a sense. And honestly, like with the language models, basically they're trained on the entire internet, right? Nobody really kind of knows what's in there, right? And like basically kind of also really dangerous, right? But I feel like if you just ask the language model something, or like any AI system, right? Okay, generate me two kissing people, right? Then I think that's just a reflection of the training data. And also maybe some other created, like whoever controls this, right? If they created this, but assuming they didn't create it, any of the training data, and just took whatever is out there in it, it's kind of just a reflection of what is out there.
Yes, exactly. And that's actually what I wanted to hint at. So whatever is out there, the data in itself is not objective, right? Some people might have this notion that since AI systems use data, they are objective. But if the data itself are not objective because they are either curated, as you said, or simply data on the internet, they don't reflect specific specific realities that we have, for example, in other cultures, in other nations, and so on. Then, of course, that's how we get biased AI results. That then, as the other listener already said, which then reproduces stereotypes, right? And yeah, these stereotypes can then become entrenched in a way.
Yeah, I'd like to add a comment there. So I think it's important now to realize that, as you say, there are curators who do decide upon what the training data looks like, what the outputs are. I mean, in ChatGPT, we do see that there are restrictions now in the output as well. Some like it, some do not like it, some do not like what is censored in a way of the output, and who decides what's right. And I think the same way that if we think about if media is produced now, be it visual arts or be it music or whatever, we should really be careful to look at who made the decision, what the output looks like, who made the decision, what companies, what interest did they have. And I think that's important. And there must be, in my opinion at least, some way to find a objective evaluation, something most people can agree on. Like objectivism is not really achievable, but to find an institution that can actually set out guidelines on how this content should be moderated. Because I do not think that this can be the sole responsibility of companies that then just follow their own interests. No, thank you. That's also all I want to say.
Thank you very much for your contribution. Yes, yeah, you gave me a lot to think about. Well, with that, I think if it's okay, I would like to actually show how we in Voxam deal with some of these questions. Okay, so
I don't see more questions in the room. I think we can really continue. Sorry, you don't see that, what I see, so just giving you the feedback.
No, exactly. Thank you very much. Then I guess we can jump to slide 22 and tell you something about Voxam. So Wirksam is a fairly large project with the goal of improving working conditions in different industrial sectors with the help of AI and work design. And what we do is we focus on the Rhenish mining area in Germany. Why this area? Well, the Rhenish mining area is confronted by 3 societal megatrends, and at least one of them was already mentioned by René. So the first one would be digitalization, which of course is not specific to this region. The second one is demographic transition. Again, this trend is not specific to the Rhenish region, but the textile industry in this area has a particularly old workforce. That's why this is very relevant. And the third megatrend is the transition to renewable energies. And this is important because it means that coal mining will phase out by 2030. And this will not only affect power plants, but also many different suppliers in the region. And so all 3 megatrends in conjunction mean that many of the companies and their workforce are dealing with uncertainties. Now, what will employees working in the coal and adjacent industries do after the phase out? How do we qualify them for other tasks and industries? How do textile companies, for example, keep their aging workforce healthy and motivated? And how do they make jobs more attractive for young employees? Those are just some of the questions that we deal with in Wirksam. Next slide, please. And to tackle the aforementioned challenges, we design AI-assisted work systems with the goal of improving existing jobs. And to do this, in turn, we follow the HCO concept, meaning that we understand a work system as a socio-technical system consisting of human, technology, and organization as equally important subsystems. Since I don't have too much time, I think, René, I will just rush through the slides if that's okay.
I would say about 10 more minutes, if that's fine for you.
10 more, that's great.
Yeah, thank you.
Next slide, please. Yes, here I just listed some of the use cases that we have, and I will focus on one, which is grinding and quality assurance, which is the second from the bottom. Next slide, please. Okay, so this use case follows the company Air Concept, which is a very small craft business with only 7 employees. But these 7 employees, they have a huge range of very different services, from engineering to custom and series production of totally different parts and products made from different materials: wood, plastics, metal. And products include, for example, furniture, trade fair constructions, elevator parts. I've even seen aircraft parts, entire airplanes. They do all kinds of things. They are highly innovative. Next slide, please. And in our use case, the company manufactures automotive rear wings made of carbon fiber reinforced plastic. Those are, pretty expensive parts. And so the customers have high quality requirements. This means that even small errors create unsatisfactory results. And thus the quality depends on the employees and their skills. And this is especially true for the grinding process, the process that we are looking at in this use case. But even worse than the quality fluctuations is that the work is purely unpleasant. It is boring, it's time-consuming. It takes about 3 to 4 hours per person per wing, just to grind the surface. And the fibers that are released in this grinding process, well, they are carcinogenic. So, employees have to always wear these full face masks with active ventilation, even in the summer when they are grinding. So it is our goal to decrease the time these employees spend with grinding by partially automating the process. And hereby we want to achieve a reproducible quality, higher efficiency, but most important, higher job satisfaction. Next slide, please. Okay, so in concrete terms, we are developing an AI-assisted robotic grinding system. And this system shall use a 3D camera to create 3D scans of the products for path planning, for a path planning algorithm. Then the robot switches to the grinding and effectors, both of which were developed and printed in-house by us, and the robot grinds the surface. After grinding, the robot switches to a 2D camera and scans the surface. It scans the surface for manufacturing defects and also insufficiently grinded areas. And both of which then have to be handled manually by employees. That's why, as I said, it's partially automated. It's not a fully automated system. Next slide, please. Okay, so as hinted earlier in the theoretical section, introducing AI into work processes comes with many questions, right? For example, which data are needed? What should the new working day look like for the employees? What should the technology be able to do and what not? And which tasks should it take over? Which tasks should remain with the employees? Which new tasks will the employees take over if some of the time is freed? And what information should be provided by the AI, for example, and in what format? And certainly there are many, many more questions that we deal with. Okay, next slide, please. So these questions can't be answered by us sitting in our ivory towers. And this GIF actually shows what happens if you try to force, or if we try to force our external solutions onto employees. This was taken from a video that we made. We actually made up a play, you could call it, to demonstrate how you should not develop technology, and also how to do it better. And we presented this play on one of our in-house symposiums. And this is part of a video that we made. And as you can see, the employee is not too happy of me giving him an AI-enhanced smartphone and telling him, well, I created the perfect solution, now he should just use it. As you see, he throws the smartphone away, and for those who are not fluent in German, he says, well, you're not even listening to me, you don't even know my problem, how do you think that you can solve any of the problems that we have? And rightfully so. Next slide, please. So instead of, not listening to the employees, just creating some kind of elaborate system that we deem useful for them, we instead use participative and iterative methods to co-develop socio-technical systems with the employees who are actually part of these systems. So here I included a few pictures taken from workshops where you can see how the employee actually presents his work and is showing us what he has to deal with, how his work looks like. In the second picture, you see how my colleague, one of the AI developers, he actually drew the human-machine interface as envisioned by this very employee. So this employee had a very concrete idea of how his work should look like and how his human-machine interface should look like. And it was so concrete that my colleague could just draw it up. And as you see in the third picture, the picture on the right, this drawing was then basically one-to-one transformed into a mock-up in Figma, and we're using this mock-up for further iterations and for the development of the human-machine interface. And on the bottom, there's another GIF taken from a different video in which we actually tested the grinding end effector for the first time. And I like this video and the GIF because it shows how the employee of Air Concept interacts with us. He is always with us every step of the way. We have monthly hybrid meetings. Sometimes we meet at the company. Sometimes we meet at one of the institutions, the research institutes, and he is always the person who explains or shows us how he wants his work to look like, which steps we have to take, which steps he has to take. Next slide, please. Yeah, here are further examples of workshops. Here we developed a new workshop format based on domain-driven design to not only develop the software, but the whole socio-technical system. And you see different employees of Air Concept, but also my colleagues and I. And together we laid out the process and figured out which parts should be taken over by the AI and which parts remain in human hands. This can be seen in the next slide, actually, or on the next slide. Yes, so what I marked here, the green box is there's a new, new events. To stick with the domain-driven design language, these are new events that are to be triggered by the AI. And using all of these workshops and also this domain-driven design concept. Next slide, please. We were able to design new work processes. As you can see on the left, this is the old process, and you have different swim lanes for the different employee roles. And now on the right, as you can see, the process is at least, as it is visualized here, it looks more complex. And we have an additional swim lane with which is taken over by AI. But overall, the employee spends less time grinding. Okay, next slide, please.
We just need to hurry up a bit, Arjan, if possible.
Okay, there are not too many slides anymore, so I'll just come to the end. So when it comes to designing such socio-technical systems and shaping human-technology interaction, there are certain things we look out for. For example, we want to ensure that the standards of work design are enforced. For example, learnability. So does the AI help employees to understand the overall process, or does it actually make them understand less? We look at the good old analog ergonomics, for example. So do the actual physical ergonomics improve with the help of the new system? For example, through automation of the grinding process, because grinding is also ergonomically not the best task to undertake. But we also look at digital ergonomics and usability, UX. Is the screen readable for older employees? Can the colorblind, for example, cope with the colors? Did we introduce cultural biases? Stuff like that. Okay, next slide, please. So once the technological elements are ready, we will do so-called work system tests to evaluate the human-technology interaction. This approach consists of interviews and questionnaires, for example, regarding technology affinity and acceptance, work experience, and other variables. And this is all done before testing the system. Then we conduct the test, which means that our participants have to accomplish a prototypical task using the new work system. And we plan to have our participants wear eye tracking glasses and health wearables. This way, we will not only observe our participants and the whole system, but we gather additional data that might hint towards problems regarding human-technology interaction, stress scenarios, and so on. And after the task has been performed, another interview is conducted in which the NASA task load index is used to assess the workload experienced by participants. Now, the last slide. Yes. here I just listed some of the data that we will use or that we will gather in the work system test and use to analyze, how participants perceive the work system, how they cope with the work system, how well it worked, how many errors they did, and so on. And with that, I am finished. The last slides only show the literature and also my contact information. Thank you very much for listening.
Yeah, maybe I will try to. So people are applauding. I don't know if you get that came through. And maybe I can also show you here. So there are really some people. It's really hard to get to all. Thank you. Adam, thank you very, very much. I think we have time for 1 or 2 quick comments or questions, maybe from your side. Is there anything? Yeah. I don't see anybody at the moment.
Yeah, very interesting. So, so the second part of your talk, what I was thinking about is if you ask the employees, right, like what they want, how they want to improve their own system, right? Like you also collecting their kind of like a little bit of bias, right? Because like not that I'm against it, but people also want to kind of protect their jobs, right, and not getting obsolete in a way, right? And in that case, you might design enhanced system that actually not optimal based on the feedback that you get from the employees, so to speak. That's what I'm thinking. And of course, from a society aspect, this is good, right, to retain the jobs and so on, right? But just that was I was thinking about.
Yes, thank you very much for this comment. Maybe 2 or 3 things that I can say to give you a broader understanding. Well, first off, work science very much different than what I actually do or would do as a sociologist of technology is normative. So it is, so we have the goal to retain jobs, to make jobs better, and so on. But of course, you're right. That also might mean that employees are not honest about what they think they need, and so on. What we do is we, of course, ask different employees and also employees that have different roles, because we take a stakeholder approach. So we don't only look at, for example, the person who uses the machine to produce goods, but also, for example, stakeholders that work in maintenance, or we ask IT and so on. So we ask all stakeholders that are somehow connected with this work system, and to try to get a broader picture of what is needed. And of course, and I couldn't show you all of the methods we use, we also actually do workplace observations. So we look at the status quo. For example, I personally looked at 4 different processes in 4 different companies. It took about 2 to 3 hours per session. So I was really in the plant and observing what the employees were doing 2 to 3 hours of a shift. So there are many different kinds of data that we use to try to participatively find out which will benefit the users and the other stakeholders most. And of course, we try to be honest with them and tell them that we will not do anything against their interests. So sometimes they are scared that we will give their the bosses data, for example, that they don't want to give them, and we always ensure that we don't do that. So maybe that explains some of our methods.
Okay. Adam, I think there's still a couple of comments and questions. It's really a pity that you're not here, because I also have a lot of things to ask you, but I will do that in Aachen next time.
Yes, please.
Yes, in the name also of this group here. I'm looking away from everybody, but to look at the camera at least. Thank you very much for your talk, for all this insight, for information, practical examples, a really, really fruitful contribution. Thank you very much, and also for being so flexible in time and also spontaneously joining us on this event. I'd love you to be here, but I think you have your next appointments. If you like, stay with us for a bit, and Once again, thank you very much for being with us today.
Thank you for having me. Unfortunately, I have to go to my next appointment, but yeah, I wish you a great time, many great discussions, and I hope to see you one way or another in the future. Take care. Goodbye.
Okay. Goodbye from the online and from the real world. Okay. We are a bit behind time, but anyways, we have the second contribution of this session here. And Jun Jano from JSPS Bonn is here to help us and provide us some information on programs, on research funding programs, also offered by JSPS. Jano-san, I would like to share my slides. Do you have the share button with you on your system? Can you share your slides?
Oh, hello. Can you hear my voice and see my clearly?
Yes, we hear you. Can you share your screen? Because for some participants it was disabled. Do you have a button for sharing? Otherwise, I will do that for you.
Maybe I can't. So can you share the slides I sent yesterday?
Yes, of course. Please give me half a minute. I will do so.
Yes.
Hello, good morning, Jano-san.
Yeah, good morning.
I don't know where the camera, here, somewhere. We just met last week in Bonn at JSPS Bonn office. Maybe I can spend a few words on your introduction. Mr. Jano is working at the JSPS Bonn office. I explained earlier that I have been working there for almost 15 years, and he will present us today the JSPS fellowship programs, funding programs for individual stays in Japan, as well as joint research projects. And we have brought some printed information material here on the desk. Please help yourself and take information at home. And of course, there are some more contact addresses available on the printed matters. Thank you. So, Jano-san, if you can go quickly to your presentation so we can all have a coffee during the coffee break. So, please, the stage is yours, the screen.
Yes, thank you very much. So, good morning. I'm Jun Jano of JSPS Bonn office, and today I'd like to give you some details about the JSPS and international programs. So, next slide, please. Yes, the JSPS, the Japan Society for the Promotion of Science, is the Japan's largest funding agency in funding capacity, and it was established in 1932 with an imperial endowment. We support curiosity-driven research based on the free ideas of researchers, both in basic and applied fields. Funding is available for all academic areas, from the humanities and social sciences to natural sciences. We take a bottom-up approach to invite applications through open calls. The applications are then peer-reviewed by more than 80,000 researchers, mainly located in Japan. They are selected based purely on academic excellence. Next slide, please. And we have 4 overseas offices in Europe, Bonn in Germany, London in UK, Strasbourg in France, and Stockholm in Sweden. We are enhancing collaboration with overseas academic promotion organization through joint grant programs, joint reviews, and other various activities. We also support JSPS alumni and JSPS researchers, Japanese researchers in Europe, including organizing academic events to promote international collaboration and expand their networks. JSPS Bonn office covers German-speaking countries, Eastern European countries, and Turkey. The next slide, please. And our total annual budget is approximately 1.8 billion euro this year, and our 19% of our budget is allocated to our core program, Grant in Aid for Scientific Research, or Kakenhi, as we call it. We receive 100,000 new applications every year, and in last year, we supported more than 80,000 projects. We also support international programs, and I will introduce them later. The next slide, please. And this is the number of researchers exchanged through our international programs. Europe represents the second largest share of researchers coming to Japan from overseas, and the largest share for Japanese researchers conducting research abroad. This slide includes figures from Germany for reference. These numbers decreased significantly due to COVID-19, as you know. In 2022, the numbers slightly improved, but are still fewer than before, especially for Japanese researchers going abroad. Next slide, please. And I would also like to introduce a little more about international program. We offer several international programs. So I will briefly introduce the program marking red line today. Next slide, please. Firstly, I'd like to introduce the fellowship programs for inviting overseas researchers to Japan. JSPS carries out a variety of invitation fellowships programs designed to support visiting researchers at various career stages and for various purposes of coming to Japan. For example, JSPS postdoctoral fellowships invite promising young researchers from other countries to Japan for a period of 1 to 2 years. In the fiscal year 2022, more than 1,000 postdocs were invited to Japan as JSPS fellows. JSPS supports their air tickets, maintenance allowance, overseas travel insurance, and a settling in allowance. The next slide, please. And first, the summer program is implemented as a component of the JSPS postdoctoral fellowships for research in Japan. The program provides opportunities for young pre- and postdoctoral researchers from North America and Europe to receive an orientation on Japanese culture and research systems and to pursue research under the guidance of host researchers at the Japanese university or research institute over a period of 2 months during the summer. To be eligible, applicants must be a citizen of the US, the UK, France, Germany, Canada, and Sweden, or other with equivalent status may apply if approved by nominating authority in one of the above countries. Applicants must be enrolled in a university graduate program or hold a doctorate received within the past 6 years. Next slide, please. And this short-term program provides opportunities for young pre- and postdoctoral researchers from the US, Canada, and Europe to conduct cooperative research with leading research groups in Japanese university and other research institutions under the guidance of a host researcher. To be eligible, applicants must be a citizen or permanent resident of the US, Canada, European Union countries, Switzerland, Norway, or Russia. Also eligible are persons who have been engaged in research continuously over a period of at least 3 years at university or research institution in one of the eligible countries. Applicants do not have to hold a PhD when the fellowship goes into effect, but have to be enrolled in a doctoral course and scheduled to receive a PhD within 2 years from the starting date of the fellowship. The period of stay is from 1 to 12 months. The next slide, please. And this is the postdoctoral fellowship standard. This program also provides opportunities for young postdoctoral researchers from overseas to conduct cooperative research with leading research groups in Japanese university and other research institutions under the guidance of a host researcher for 12 to 24 months. Applicants must be a citizen of a country that has diplomatic relations with Japan. As for the academic qualifications, applicants must hold a doctoral degree received within the past 6 years or must be scheduled to receive a doctoral degree before the fellowship goes into effect. Next slide, please. And let me also introduce the program for mid-career and beyond. This invitational fellowship program's long-term is to invite overseas researchers with excellent records of research achievements to collaborate with Japanese colleagues in carrying out research through long-term visits. Candidates must be a citizen or permanent resident of a country that has diplomatic relations with Japan, and candidates must be a researcher in a position equivalent to a university professor, associate professor, or assistant professor in Japan, or at least 6 years after obtaining a doctoral degree. The period of stay is from 2 to 10 months. Next slide, please. And this short-term program is a program to invite overseas researchers with excellent records of research achievement for short-term visits to Japan and provide them opportunity for discussions, opinion exchanges, lectures, and other activities. Candidates must be a citizen or a permanent resident of a country that has diplomatic relations with Japan, and they must be a researcher in a position equivalent to a university professor or associate professor in Japan. Emeritus professors are also eligible. The period of stay is from 14 to 60 days. Most researcher in Japan needs to apply for these invitational fellowship programs, either long-term or short-term. So if you are interested in them, please contact your colleague in Japan. And for more information on those programs, please refer to the application guideline on the JSPS website. Next slide, please. And secondly, I'd like to introduce bilateral collaboration. Under this scheme, JSPS and its counterpart agency jointly select project and provide matching funds for the project, conducting joint research or joint seminar. Currently, JSPS has MOUs with 37 counterpart agencies in 29 countries. In Germany, we have been carrying out bilateral programs in the form of joint research projects and seminars based on MOUs concluded with DAAD and DFG for more than 50 years. We jointly select with DAAD and provide matching funds. Next slide, please. And these are the partner agency in Europe for bilateral cooperations. And next slide, please. And this program also supports joint research or joint seminars between Japan and researchers in all countries which Japan has diplomatic relations. Support of funding agency in a country of a research counterpart is not mandatory, but they must fund their own grant for their own activities, since JSPS only supports Japanese researchers' activities. The next slide, please. We also offer the grant programs Core-to-Core program for large-scale research networks. We grant 18 million Japanese yen per year for 5 years for the project, conducting collaborative research such as joint research, seminars, and research exchanges between institutes in Japan and other countries. Projects are expected to create research hubs for advancing multiracial international collaboration and also fostering talented young researchers in Japan and around the world. Next slide, please. Next slide, please. Yes. I would also like to introduce a little more about international program in Kakenhi programs. We provide 3 grants types for overseas research for young researchers, international joint research including. International reading research is started from 2022 for facilitating the participation of leading research groups in Japan in the global network, allowing them to assume a pivotal role in obtaining significant scientific outcomes. Programs for international joint research can support the invitation of international researchers and the involvement of graduate students and postdocs through the awarded projects. Next slide, please. So these are the reviews criteria for bilateral programs, so please refer to them for important points. And additionally, please check the website in the materials for information on how to find Japanese researchers. Next slide, please. And this is the end of my presentation. And if you have any questions, please feel free to contact us at this email address. So thank you for your attention.
Thank you very much, Jan-san. Maybe there are already some questions now here on the floor in the audience. Not yet, and yeah, it's very nice to have your email address here available on the screen, so we can get in touch with you and your office. Thank you very much for sharing time with us and introduce the JSPS fellowship programs. I think now it's my part to invite all of you to the coffee break. One more question here.
Sorry to be late with my question. You've been talking a lot about research exchanges. Do you also do teaching exchanges? Like a German professor visiting Japan and a Japanese professor visiting our university here. Is this also in scope or is that out of scope?
Sorry, could you ask that question again, please?
Okay. Your presentation focused on researchers. Now
Yes.
I'm talking about teachers, professors teaching courses, lectures at universities. Do you also include teaching exchange? Meaning, I would like to invite a Japanese professor to teach here in Wiesbaden, or I would go to Nagoya, let's say, and teach my class.
Sorry, can I change to answer that? Sorry. Just a moment.
Sorry for interrupting. My colleague could not answer you, but JSPS, the funding agency for research itself, and I'm sorry, but we could not cover the teaching activity between Germany and Japan.
Okay, thank you.
Yeah, you're welcome.
Thank you. Okay, thank you very much. Okay, no more comments from Bonn and no more questions here from Wiesbaden. So we close this session and we will meet again at 11:30. No, it's in, okay. Sorry for that. 11:30 here in this room and the coffee break is in building A. Thank you very much and see you soon.
Thank you.
Greetings to Bonn. Thanks for being with us. Okay, so we're back from a coffee break and also from the coffee breaks, maybe the remote coffee break, so to say. And we have a small shift in the schedule due to a special technical setup here. So we have a presentation with music streaming and now everything is set up. So I'd like to give floor first to my colleague Sebastian Eck. And afterwards, we will have some greetings from Professor Albert from Graz University about the EJEA. We shifted that from 9 to now. And then we will go to Javad Hakbin and later on to Marius. So I would like to ask you to stay a bit longer, 10, 15 minutes for the lunch break so that we have everything now close together. Now we'll stop talking because I'm pushing you guys to keep the time. So the floor is yours.
Well, good morning. And good evening to our Japanese friends as well. My name is Sebastian Oliver Eck, and I am a member of the Music Automaton project at the University of Music Franz Liszt Weimar. Our team, which includes Professor Jan Anneke, Alex Vaughan, Pia Stoik, and myself, has been working since November or October 2023 on exploring how generative AI can be effectively integrated into music theory education. Today, I'm excited to share with you the initial results of our research and the motivations behind our project. Well, let me start. I think you have all observed over the past years and also in the presentations of our colleagues today, the application scenarios of Gen AI. These are extensive and in many cases, they hold considerable potential, even for non-expert users. With an equally fast-growing number of application scenarios of Gen AI within the arts, including the visual arts, AI-generated paintings, movies, but also literature and music, we see ourselves confronted with having to ask us important questions, rather fundamental questions. For example, only one of which being, of course, the relationship between artificial intelligence and human creativity, which will be in the center of my presentation today. Whether you consider yourself a creative person or not, it is important to remember that yes, while the widespread dissemination of user-friendly GenAI applications does indeed pose significant ethical and legal challenges, particularly in the arts, its presence also provides an opportunity to get together with researchers from various backgrounds and tackle fundamental questions, such as I showed earlier, what constitutes human creativity in times of its artificial replicability using artificial intelligence, or how can Gen AI aid us in our own creative processes? Well, of course, it's not possible in any way to sufficiently debate these questions or even find an answer to these questions in the following 15 minutes of my presentation. But through giving you some insights into the works of our research group, I would like to first introduce you to the potential application scenarios of generative AI within the field of music theory education, and secondly, discuss possible implications for enhancing or evolving music theory education in a higher education context. Well, in recent years, the use of artificial intelligence, or in particular deep learning-based technologies for music generation, has seen a significant rise in scientific publications, where these rather recent advancements have found its way into various commercial AI applications for music generation that kind of assist musicians and composers. For example, by creating basic compositions, by providing new music material, or by generating orchestrations in various styles, as the next brief example will show. Well, this basic support, of course, can arguably, where we can all argue about its quality and its usefulness, of course, allows musicians to focus more on the creative part of their work. However, AI application in more sophisticated musical areas, such as replicating historical musical styles, remains very limited. While machine learning can successfully produce chord progressions, on the other side, achieving melodic invention or integrating complex phenomena such as melody, harmony, syntax, and form continues to prove very challenging, if not impossible. Hence, overcoming these limitations holds significant potential for advancing music theory education. Well, to give you some context, music theory at the Master of Music level often involves analyzing and artistically reshaping music from the past, often through recomposition. Increasingly, these results are also performed, such as when fragments by well-known composers are completed. These style imitations, though they only, of course, can approximate the historical example, are a popular practice among our students in our university as well, for various reasons. One, of course, is mastery of these styles is crucial for our students to deeply understand the techniques and expressive nuances of past composers, often referred to as musical style. In the end, this supposedly enables them to analyze, interpret, and creatively engage with the music on a profound level. Hence, it's a crucial step in helping them develop their own compositional style, for example, if they choose to become composers at a later stage themselves. Well, recent advancements in generative AI for prompt-based audio generation have produced, I think, really impressive results. For example, commercial web applications like Udio, they can generate audio that mimics the sound of classical composers in a rather convincing way. Comparing real compositions with these artificial creations which we'll do now, can very well illustrate as how close Gen AI technology in its current form already gets to the original. So let me start with an example. Well, this, of course, was an original, but now I will show you an artificial version. On the right side, you find the prompt used to generate the audio. Well, while these audio examples are indeed impressive, I believe, they do pose significant limitations in their usability within music theory education. In this context, usability refers to being able to discuss and debate stylistic nuances, of course, in order to understand the music at hand at a more profound level. At the end, this process aims to enable students to answer questions like, why does this particular composition sound like a Mozart string quartet and not like a Brahms quartet? Or more generally speaking, what are the determining parameters ultimately constituting musical style? One big issue here being, of course, artificial audio files like the AI-generated example at hand do still lack corresponding sheet music representation of the music contained. Without sheet music representation, students and educators, they cannot really perform detailed analyses of the inherent musical structure, for example. No harmonic progression is being able to looked at, no motives and other musical components that somehow, and that of course people can argue, they constitute musical style. So debating these is, as stated earlier, fundamental in the process of learning to reproduce stylistic nuances. Well, this gap in AI-generated music inspired us, our team, to create our own transformer model that not only imitates historical musical styles, but also provides the corresponding sheet music notation for analytical purposes. As I stated earlier, particularly this feature is essential for music theory education, as only sheet music allows for comprehensive analysis and engagement with the music at hand. Well, our goals thereby are to create our own Gen AI that is capable of understanding, first of all, and secondly, generating complex symbolic musical data, as only symbolic musical data can directly be displayed as sheet music notation without any information loss. This leads directly to our second goal, making the application accessible and usable by a broad audience without programming expertise. In other words, musicians, musicologists, and music theorists who would engage with the AI in a creative dialogue. Well, to achieve this goal, we focused on a few key areas. First, of course, we had to find new methods for music tokenization. This means creating new ways to represent musical data in a format that can be understood by neural networks or more specifically large language models. So just feeding it an XML file does not really bring any good results in the output. Next, we trained a transformer-based AI model. We are using the various data sets, of course, to train our model, including some data that was artificially created, like some musical data was artificially created by algorithms. So we defined certain rules, how pieces should look like, what harmonic progressions, melodic progressions they should have. And we just generated some basic musical material to have a larger database for training purposes. So we have a few things that you have not yet implemented, but looking forward to is that we would like to use some sort of algorithmic evaluation of our generated output. This, of course, means we have to set up some rules that will automatically assess and also exclude material if necessary, if generations by the AI are not suitable or are not adhering to any musical rules that we know they exist in this particular styles. And finally, we are exploring the integration of reinforcement learning in our approach. Basically, since we do have a dialogue with the user, we think that it might be beneficial to take the input of the user, some results they liked, some they did not like, to use this to further refine our model over time, of course. Well, yes, I think exactly. And our second goal is to create an create a way to interact with the AI in a creative way, in a dialogue way. So this also means that we have to find an interface suitable for this task, and we opted to do a web application, as this would be the most accessible form, basically, for our students to access it. We had some projects before using algorithmic models to create musical compositions in various styles. But yeah, this worked very well, providing this application on a platform online. Well, of course, key point is to design this kind of musical question and answer game, which means that we should allow for an exchange of musical ideas, so to say, between the model and the students interacting with the model. And central to all of this is, of course, some sort of human-machine collaboration. This means that whereas the machine does help our students, the human element stays still in the focus, in the heart of our research project. And lastly, we do, by contributing this project, or we hope that we can find ways to improve the music education in our college by introducing a system that can assist our students practicing composition of styles, giving it feedback like 24/7, which is not something any teacher can do, but to give ways to refine your own work by using this model. Well, I would like now, of course, give some demonstrations of the music automaton. I think it's time to show what it can actually do and what it cannot do yet. So I would like now to show you some compositions that were entirely generated by our current alpha version of the music automaton. These unindented pieces are just, as the other examples showed earlier, various imitations of Mozart string quartets. And even though the results do vary in their overall quality, I think they will help very much to exemplify the capabilities and limitations of our current AI model. So whom of you are musicians might be familiar that some sort of medium to long-term memory is necessary to effectively represent musical style and musical compositions. I mean, you might have heard of terms like sonatas, for example, that have a certain inherent structure. And if you try to replicate those forms, our model also have to have this kind of understanding. So, but please bear in mind what we are showing you now is our very preliminary results of our AI output. Well, of course, so as in language, musical structures, they often contain recurring melodic or rhythmic patterns, and which are crucial in a way for each compositional technique. And yeah, I would like to show you now that our model is indeed a bit capable already of imitating these structures. So something we noticed is, of course, that we can see that the longer the piece goes, the more it's tending to be obscure somehow. Of course, I think we can talk about the reasons later. I'm gonna wrap up a bit. So one last two examples that I want to show is basically the development of next slide here. Yeah, so key element is, of course, the continuation of musical input that you deliver to the model. So basically, we give it one bar, the first measure here, and then ask it to continue the composition in various styles. So these are just two examples that I found particularly good. Briefly show them. And the last example for today. So about the user interface, very briefly, you can see it in the background. We give the user, so this is just for testing purposes. This is not the final version. It's just to see whether the whole principle works. You can choose between several styles. You can then push the button to generate. And as soon as you push the button, it takes some time, and you will be presented with some output, which you then can download or just play immediately in the browser. Or just repeat the process if you would like to generate something else. Basically, we are using labels, basically data annotated with labels that we then, just choose in this menu, and then the AI is basically producing something. So I would like to very briefly now say last words. 3 minutes, okay? Wonderful. Thank you. So yeah, basically challenges that we had, of course, is that music tokenization is very complex. We had to devise some new methods to accurately represent musical notation for AI processing. Even as transformer models, of course, they can be applied to any kind of data. If we did that, we found that the output is really not good. So if you want, you have seen the file before, if you want to have coherent output that it can be displayed in our, like in any kind of notation software, the file has to really be complete and correct. There has to be a certain structure. And also what we found out is that we have a need for larger data sets too, to train our model, to expand the capabilities, of course. And if you think about the amount of data that was used to train large language models, it's a really small number of pieces, which is why we had to use artificial data to support this. But one other thing I want to add, if you take together, that's my observation, if you take all piano literature that has ever been existed by the major composers and you would digitalize them, it's still a relatively small amount of data compared to language. So there might be an issue too. Right, and our significant impact is, of course, that we try to advance education. I think it's a good way for students to engage with AI, to learn the basic capabilities and limitations, and not just. And how I would say it's always best to learn those things in an applied way in your own discipline. Like if you come from a different discipline and you find a tool that can help you in your own studies or in your own work, you are very willing to accept it. If it's not like an academic study, but an applied study. Of course, this teaches digital competencies of like what can you do, what can you not do. But also, very importantly, it's important to give our students the chance to have some support if they, for example, struggle. So, and last slide, if you would like to use the model yourself, please contact our team. I forgot to put my email address there too. But you can contact our project coordinator. You can access the QR code here. There's the page. There's going to be a web page that hosts our model very soon. And if you would like to try it, we can provide you a private link to our model. We cannot make it public because the server is not really secure, but it's going to be secure and available very soon. So thank you very much. That was everything today. If there's still time, I would be glad to have discussions. If not, we can talk in the lunch break too. Yeah.
Very much. Are there some questions here in the room? Or maybe also in the chat you can post questions, I guess.
Yes.
Yeah. Yes, please. I will hand over the microphone.
Thanks. Sorry. Thanks for your contribution. I want to ask about different music styles. Did you just try classical music or also jazz or house music? And did you find any differences?
So two things to that. Our database is currently mostly Western classical music, but as long as you can represent anything in sheet music notation, we can apply our tokenization algorithm to that as well. So we are glad if you can, or anyone can provide training data. And the second thing is that would be interesting. We found that if we, for example, you take compositions from Mozart, a certain sonatas, piano sonatas, but you also give it Bach chorales, for example. We found that both genre and both composers were getting better in the way stuff was generated. So we might think that even if the two genre or the period is not related, they can still learn from each other, which of course implies, or yeah, well, we can know that music theory is connected and it has been a development. So let's say if you add music or like non-classical music, right? If you add pop music, there are still certain rules that apply to both fields. Voicing is different, harmony is different, but there are certain rules and connections. But I'm very curious what happens if we do add, for example, music that is not Western classical or not even Western, for example. That would be interesting too, to see what happens next. Yeah.
Thank you.
Any more questions? Not here. Then thank you once again, Sebastian.
Thank you too.
Interesting presentation. And I would like to hand over to our next speaker, Professor Dr. Dietrich Albert, who is the chairperson of the European Japan Experts Association, EJEA, He's a professor at the Cognitive Science section of the University of Graz in Austria. Dietrich, we can see your slides here on the screen, and the microphone is yours. Thank you.
Thank you. I hope you can hear me. It's really a privilege and a pleasure to present European Japan Expert Association, and in a term of welcoming and greetings from EJEA. And I will add a little bit about Cognitive Science section at University of Graz. And I would like to have the next slide. On November 4th in 1995, Japan experts from 11 European countries and from European Commission assembled at the Japanese-German Center Berlin in Germany in order to establish an alumni organization for the participants of a Japan Fellowship Program funded by Japanese industry, the European Japan Expert Association. Next slide, please. It was strongly felt that such an association would help to generate and disseminate knowledge concerning Japan, the most stable and reliable partner in Asia, amongst European scholars, professionals, the business world, and especially decision makers. Next slide. A European organization of this kind is necessary because not only issues regarding trade and industry, science and academia, but also a gradually growing number of political fields on the international level are now more and more issues for the European Union and not only a nation state alone. Next slide. After 20 years of existence, European Japan Experts Association was looking for new opportunities to establish an advanced, sustainable interdisciplinary network in order to provide a reliable foundation for enhancing the links between Europe and Japan. In this process, EJEA has started, for instance, an annual conference series since 2018. Next bit, please. Here's the list of the topics of these conference series since 2018. I will not go into details. You easily can imagine that a strong connection to computer science, especially artificial intelligence, is in the content of all these meetings and conferences. And our next conference, please, next slide, is scheduled for November 5th until 7th in Linköping in Sweden, and it's the 6th of this series. The title of this international hybrid conference is Future Knowledge and Competence for AI-Driven Innovation in Europe and Japan. Please go to the homepage of this conference. And by the way, the 7th EJEA conference in 2025 is scheduled to be in Japan in 2 years. Next slide, please. Many thanks are going to all the co-organizers and sponsors of the EJEA conferences and to all the supportive EJEA members, and especially to Sabine Ganter-Richter, who is the General Director of this organization. Next slide, please. I want to suggest to visit the homepage of my group. First of all, to visit the homepage of EJEA. It's ejea.eu, and please become a member of the European Japan Expert Association via using this link. That would be great. You are very welcome. And please allow me to add a few words about the Cognitive Science section, which I'm leading. Next slide, please. The Cognitive Science section is an interdisciplinary research group consisting of psychologists, computer scientists, and mathematicians at the Department of Psychology, University of Graz in Austria. From 2009 to 2019, the Cognitive Science section has been located at Graz University of Technology in Austria and Graz. In general, the Cognitive Science section targets research fields where cognitive psychology or cognition meets technology. More precisely, Cognitive Science section's research areas encompass the fields of technology-enhanced learning and related technology, decision-making and decision support systems, adaptation and personalization, cognitive modeling, human factors in secure society research, and user-centered evaluation of computer applications. Next slide, please. It follows a multidisciplinary approach to assemble solid psychological theories, methodologies, and technologies in formal frameworks that guide and integrate research and development and innovation. The group has worked and gained experience in more than 30 research projects on national, that means Austrian, and European level in the context of technology and learning, secure society, cultural heritage, smart cities, and so on. For further information, please visit our homepage, cognitive-science.at. Next slide, please. If you're interested in jointly submitting and running cross-disciplinary third-party funded research, development, and innovation projects, please visit the homepage of Cognitive Science at .at projects and contact me via email dietrichalbert@uni-graz.at or phone me by my mobile phone. Here is the number. Next slide, please. Thank you very much and have a great GRANITE EJEA intercultural workshop. Many thanks again. All the best to Germany and to Japan. Thank you.
Thank you very much, Dietrich, for your introduction on EJEA and also on your cognitive science section. Are there any questions here in the room? I briefly introduced our 2024 conference this year in Sweden, and I found some interested people here in the room, so maybe we can attract some more contributions also for the conference in Linköping. So now we will proceed to the next. Okay, to the next presenter, Javad Hakbin. Are you already online? He's here. Oh, you. I'm sorry. I'm sorry. I was not sure.
Thank you so much. Okay. Okay.
It just has a lag of 2 seconds because it's streamed. So
Okay. So should I start?
Yes, please.
Okay. So hello everyone. My name is Jawad. I came from Japan. I'm working as an assistant professor at Kyoto University, one of public university located in Kyoto, Japan. So today I'm talking about our project, Facilitation Chatbot. Whether Facilitation Chatbot is a software programs designed to enhance online education's learning platform. So we want to check whether the Facilitation Chatbot can enhance the confidence of outcome learning in online platform or not. So as we know that digital technologies has been used to support online process like online educations, online discussion, online services. And however, research shows that students in online settings are feeling more isolated. And it's because, it is because due to social context, online communication and interactivity issues. The recent advancement in AI help the researchers and engineers to build software as agents and deploy them in online process to facilitate the process. So a tool designed to enhance the students' learning. Okay, so the tools designed to enhance these activities. However, the effect of chatbots on student learning confidence is relatively underexplored. Here, due to scalability and other constraints, lectures or a lecture assistant cannot be properly work with the students. So that's why, for example, when a teacher conduct a lecture using Zoom, and after that there is no post-lecture interactive discussions, because maybe a teacher might conduct a lecture for students, a class size of 40 and so on, and there is no interactive, in real world, that is the problem. So that's why we use automated agent on behalf of human to support the process taking over the task. So to address this, we designed this study, the comfort and confidence of students increased after post-lecture interactive discussion facilitated by these chatbots. So today, we are talking about this. So first, we designed this study to investigate the effectiveness of these bots. So specifically, we wanted to investigate the attitude in learning outcomes of computer science undergraduate student enrolled in course using Zoom and Discourse system. Discourse is a text-based online discussions where people use for collaborative shared understanding and text-based chats. So with and without facilitating chatbots, we deploy these chatbots into the Discourse. So the lecturer used Zoom to deliver his or her lecture, and after that we had post-lecture discussions using Discourse, with only Discourse with our chatbot. So so this is like so our approach, we conducted a social experiment and follow-up self-report study to answer our research question and test our hypothesis. So in today's lecture, just talk, I'm going to talk about the only follow-up self-report survey of the students. So yeah, so we designed those chatbots based on LLM, but the human Japanese Professional Association of Facilitators created facilitation messages, and based on the course syllabus, and then we fine-tuned them using LLM. So yeah, our goal was to evaluate whether our proposed approach could enhance a student confidence and learning process or not. Confidence in outcome, learning confidence, something like that. So our hypothesis is that the students' confidence and comfort in learning platform facilitated by the in post-lecture discussion facilitated by chatbot is more than the average compared to the learning platform without chatbot facilitation and interactive discussions. So this is like step one, Zoom, teachers use facilitate to deliver lectures, and after that, there is a discussion or not discussion, but in our setting, there was interactive post-lecture discussions, whether it was only Discourse, and another treatment group was the Discourse with our agent. So there's a question was, how does the learning process facilitated by these chatbots influence confidence formation in learning platform? How does interacting with a facilitating chatbot during pre and post-lecture process affect the student confidence in learning topic studied during a lecture? So our samples come from the higher educations, the two lecture, same lecture, they have assistant professor with PhDs, and 40 female student and 40 male student, B1 and B4 from computer science students. So the lecture content was the same. The topic was role of information on society. So this is the procedures we created through a recruitment agency, where we recruited the subjects and from the universities, and then we follow up this procedure to divide them into groups of 4, a group of 20, 40 using Zoom, and then we, in the post-lecture discussions, we classified these 40 into 4 groups of 10 people. So this is the general settings. Like you can see that this is session 1. Day 1 had 3 sessions, pre-discussion because to know each other, then Zoom, main lecture, and then post-discussions. And here was like our chat A, chatbot A, chat B. Chatbot A was like to facilitate the brainstorming and to help the student to get to know each other easily. In this chatbot 2 was somehow informed based on the course lecture. So yeah, this is the day 1 treatment, and after that, the day 2, there was also 3 sessions, Zoom, and then post-discussion lecture, and then interactive discussion, and then there was a self-report survey by the students. So in today's lecture, we only focus here. So yeah, these are actually the technical things like agent behaviors and session way. How does it work? Actually, like because of time constraint, I cannot go into details. And this is agent posting timeline. This is human AI interaction in session 1 of day 1. And this is the Zoom only. This is session 3, facilitated by agent. So how the facilitated facilitation behavior have been programmed. These are the facilitated chatbots or interaction among the students. Yeah, so surely our findings suggested that the comfort and confidence of student increased after post-lecture interactive discussion facilitated by AI chatbots. So there was a test comparing the responses between Group A. Group A is the discourse without chatbot, and the Group B is discourse with chatbot. So the participant with setting B feels substantially more confidence about the topic studied. Then it is the confidence definition here is that the outcome of learning. For example, if you review a paper, you say, okay, I'm confident. My confidence level is this. Okay, I'm confident to review this paper. For example, I'm confident that I learned this one. So it is the confidence of that learning outcome. So they say the students who interacted with chatbot in post-lecture discussion, they said, I'm confident that what I learned during the lecture, I learned that or something like that. Because it's not because of AI chatbot, it's because of human contextual touch. And with AI chatbot, incentivization of the students to enhance those human knowledge touch among other students. So somehow we can say that it is because that AI somehow incentivizes students to engage with each other and outline the core points which they learn during the lectures. So we discussed the difference how AI can support online process, and actually it was challenging to eliminate the bias here when conducting this type of approach. Also it's only one number case. We need to do a proper cross validations, and we have to need to include more statistical measure for a more comprehensive analysis. So yes, so we designed a facilitation chatbot to assist students enhance their critical thinking and shared understanding during the post-discussion lectures. We conducted a social experiment to check this, and our findings suggest that chatbot facilitation and engagement with the students increasingly increase the comfort and confidence of students' learning outcome. So the proposed approach can be used as a helpful tool to enhance shared understanding in lecture content, proper and critical understanding in areas where the formal education cannot be accessible and so on. For example, during COVID-19, almost everybody used online learning platform, but nowadays, so we have some countries, some communities where the formal education is already banned. For example, Afghanistan, so girls cannot go. So such kind of initiative can somehow support a democratic process for, like, say, for girls to enhance their learning activities. So the future direction for research is across site large-scale social experiments needed to further validate this approach, and also the effectiveness of AI-assisted in tool intervention and facilitating learning platform need to be properly validated. We will also consider both discussion content and self-reported study, because in this talk, I just reported self-report study. We need to also check whether the discussion content, for example, to test whether student participation increased, the number of long explanation given by student increased or not increased, while checking these two settings. So if today we just reported on the self-report study, where the student just reported their activities. So these are the references. If you have any questions, this is my email address. So I'll be really interested to, if you want to proceed to talk how best we can proceed to collaborate with each other, you can note my email address. We can discuss how best we can work together in the future. Thank you so much. Yes.
Okay.
Thank you so much for this very, very nice presentation. So I personally am also very interested in how to make ChatGPT particularly more applicable or usable in our education, in our colleges too. But I have a question. So being confident in your learning outcome does not necessarily imply that it's correct what you learned.
Yes.
And particularly if you use ChatGPT or other models like those, there's a big danger of just repeating over and over some facts that are not correct. So in this study, I think it was not part of your measurements on how correct or the study material was, but how do you think about that? How to make sure that it actually is correct information?
Thank you very much for the question. In order to regulate that consensus, we just created our chatbot based on LLM, but the facilitated messages is based on the course syllabus, which wrote by professional facilitators, human facilitators, and we fine-tuned that one. So somehow we can minimize the consensus of your questions here, but also regarding the confidence, we of course, you know, it doesn't we doesn't have a proper definitions here. For example, how we can interpret that one, the learning outcome confidence, something like that. But proper, it doesn't mean that you correctly understand or you not understand. We not take that into consideration because it is based on the self-reported study, right? But if we just check the content of discussions, and then we can somehow answer your questions. But right now we cannot answer because we don't know if their content of discussion to check the validity in value and the quality of that content. We can answer that one if this interaction help them to properly understand based on factual fact, or there's like based on like virtual fact, something like that.
Oh, thank you. Just some additional to that.
Yes.
So it's not very scientific for me to say that, but I was reading a study at the name I forgot, but I can only remember the outcomes, which was that there were two groups of programmers tasked to write encryption algorithms using ChatGPT. The one does, the other not. The one using it felt much more secure about the outcome and the correctness of their algorithms developed, but they were very insecure.
Yes.
Because using old algorithms, encryption algorithms, whereas the other ones felt less secure, but they were much better algorithms.
Yes.
So my question really is like, would there be a way to make a study evaluate the correctness of the outcome by supporting it with ChatGPT, for example?
Actually, the social personality profile of our agent here is just to assist. It's because of the scalability problem of human. We cannot replace the human role, I mean, teacher assistant role or teacher role here. What we can do, just like environment, we have scalability issues, constant, other constant. We can deploy this, and the personality profile our agent is very regulated. So we cannot make it like open like a ChatGPT or something. We regulate it because we know that there is still not much study to understand how the ChatGPT works. It might help or not help. That's why we are somehow regulating our chatbot. So that's why. But actually, unfortunately, I cannot properly answer your questions because there is not much. We don't have much experience to answer that question. Right
Okay,
now.
well, thank you very much. Very interesting. Thank you.
Thanks so much.
you. So maybe we can hand over to our next speaker, Sophia Sahab. You're going to give your contribution.
If we could take your precious time for another 10 minutes, because then we will be over the time. Whoops, over time. So, but then we are back in time after lunch. Okay, so then Sophia also has your 20 minutes. I will quickly switch your presentation.
Okay, thank you very much for giving me time. I will try to make it as short as possible. Yes, so my today's presentation is a comparative analysis of AI facilitator impact in online discussions. It's a cross-cultural study. We in Kyoto University have developed, our team have developed a discussion platform. It is called DAGRI. The discussion platform is like a large scale group discussion platform that it has a facilitator, AI facilitator that facilitates the messages. Because when we have group discussions, very large group discussions, it's too difficult to have human facilitators to facilitate the discussion and make a direction to the discussion. So in that group discussion platform, the AI facilitates messages based on an issue-based information system. That is, actually, it was developed before we have ChatGPT and other large language models. The AI in our discussion platform first classifies the opinions into issues, ideas, pros and cons. And then based on that classification, it posts facilitation messages. Like if a person shares an issue, it asks participants to have ideas on how to solve the issue. And if a person asks for share some ideas, it asks the other participants to share some pros and cons of that idea. So it is how it works. And we have used that discussion platform in Japan, in Afghanistan, in Indonesia, and many other countries. But we found that somehow it works very well. It's welcomed very much in developing countries like Afghanistan. And it works in Japan, but it was much more welcomed in Afghanistan. And we had a contract with the previous government, with Kabul municipality, and we were using that platform for participatory planning. And then we thought, how about to have some similar participants from both countries, like Japan and Afghanistan, and see if we have same level of education and standardize everything between participants in Afghanistan and Japan. How it will be like, we can see if the messages and replies to AI and these things are different between these two countries. So this is how we selected. We selected Afghanistan. I'm originally from Afghanistan and Japan, currently living there. And we made these two countries as our case study areas. And then we have these research questions on, for example, how the AI or the chatbot influence on users' willingness, or how the chatbot can affect users' willingness to express more opinions, and users' willingness to express in chatbot-assisted online forms influenced by their interactions, surroundings, and social context. So this is our study hypothesis. That facilitating chatbots significantly impacts discussion development with groups knowledgeable about discussion topic and ordinary people. I will discuss this, what is this knowledgeable in the methods. So we recruited 32 subjects. It's a small scale experiment, and We had 16 subjects from each country. We had groups of 4 members. We call them ABC. These groups had 2 male and 2 females, and we had 4 discussion topics. They discussed each hour for each discussions. We have such kind of facilitation setting to set facilitation, like for each message that a human shares, we can have 1 facilitation message by AI, or for 3 messages by human, we can have 1 AI facilitation, or for 5 messages. We wanted to see if more AI facilitation is better or less AI facilitation is better. But I think in this presentation, I will not discuss about that, but we had such kind of facilitation settings in the discussions. So we had, before starting of the discussion, we had knowledge evaluation questionnaires, and because we had some specific discussion topics, we made questions regarding that topic, and to see what people are more knowledgeable about the topic and who are not knowledgeable. And we give points to them, and we can see that group A and B were more knowledgeable, and group C and D are less knowledgeable. And this is the results. Actually, I discussed about types of facilitation. I will discuss about that here, but it's not written. In Afghanistan, we had like with each facilitation type, like more facilitation, less facilitation, the opinions shared by participants were different. But in Japan, with all facilitation types, we had similar kind of human opinions, human messages. So it was not that different in Japan, but in Afghanistan, it actually was different. So for the first one, we can see that the impact of chatbots on user willingness to express their opinions is significantly influenced by the user's knowledge of discussion. So participants who had knowledge of discussion, they shared more opinions. As you can see, group A and B, and we are comparing group A and group D. That is, A is knowledgeable, D is not knowledgeable in Japan and Afghanistan. And in both countries, we can see that those who had more knowledge about the discussion, they shared more opinions. And this is the same too in both countries. And I can come here. I cannot see. Yeah. And our second finding was participants in Afghanistan engaged more extensively in discussions, possibly due to cultural valuation. Because we had in previous experiments, we found that we have more opinions shared by Afghan participants when we do experiments and less engagement in Japan. And in this experiment, although we had similar participants in both countries, but still we had, for example, here we are comparing the characters that were shared or the length of the words that they like, the length of the messages. And we can see that we have that much more in Afghanistan than Japan. And also, as I said, we have AI classification of messages, issues, and ideas, pros and cons. And in Afghanistan, we found that people share more issues and more ideas. But in Japan, people do not share much issues or ideas. They just talk about pros and cons of an issue or idea. They are kind of making argumentation. But in Afghanistan, just more sharing issues and ideas, and that continues like this. It is kind of obvious that we have more issues and problems in Afghanistan than in Japan. So although smallest experiment, but we had other elements that I did not discuss in this presentation, but we found somehow that AI facilitation, how it works in Japan, a developed country, and how it works in Afghanistan, a developing country, that people are not used to using AI, especially that we conducted this experiment in 2020, I think. So they were not much used to AI and using technologies, using discussion platforms. We wanted to check how it works, but kind of it was important for us to find such kind of things in this study. So, and this is also, we found that user expertise is important in both developing and developing countries, developed and developing countries. So, and also people from Afghanistan may tend to engage more socially than individuals in Japan, where interactions might be more reserved. We would like to check this if it is the same with like Western countries, because in Japan, people are not so much making like social connections easily. But in Afghanistan, of course, it's different. But I can see coming here, like a few days ago, I can see it's better here. We can make better connections. So we wanted to, I think we should check it and compare these countries as well, and to see how it works, AI. And it's important to know, because we should have AI facilitation based on context, not same facilitation or same AI for all the countries. And we would like, as a future direction, we want to make more control experiments and larger scale experiments, and using much more developed AI, and see how it works in different contexts. Thank you very much.
Thank you very much, Sophia. Also, again, here the question to the room and also to the chat. Are there any questions for Sophia? Everybody's hungry.
Could you tell us a bit more about this facilitation? What was the differences between different types of facilitation?
Yeah. Let me. Yeah. These different types of facilitation, like we had for one discussion topic, we had for each opinion, for each message that a participant shared, we had a facilitation by AI. For example, when participants said how to solve the traffic issues in Afghanistan, and then the AI said, like, ask other participants, like, please give some ideas on how to solve this. Yeah, but when we have 1, 2, 3, like AI waits for counts three messages by humans, and then posts one facilitation messages for one of these three. And 1 to 5 is like 5 messages by humans, 1 facilitation message by AI. Usually, if we have so many AI messages, it's not like people will have a lot of messages to read. So we wanted to check which ratio is best. And actually we found that like 1 to 3 is the best, like 1 facilitation by AI for 3 messages by humans.
Chatbot is only facilitating, it is not providing any opinion in the topic, so only facilitating the discussion.
Yeah, okay. Yeah, that's it. Yeah.
Thank you. Any more questions? If not, I think we can start our lunch break, and everybody's hungry, going over to the Mensa, which is just opposite if we leave the building here, and then it's next door. And we will be back after lunch break at 2 here in this room. So enjoy your lunchtime.
Thank you.
So, wir sind wieder zurück von der Mittagspause. Gemäß der Teilnehmerzahl oder der anwesenden Personen kann ich sagen, wir können ruhig mal auf Deutsch weitermachen. Und bei Bedarf switchen wir wieder auf Englisch zurück. Willkommen zurück an die Remote-Zuhörer, Zuhörerinnen und nochmal an euch alle hier im Raum. Es wird euch alles vielleicht ein bisschen falsch gesagt, also an die hier sind. Es ist ein bisschen ausgedünnt nach der Mittagspause und hoffen, dass sich noch ein bisschen füllt. Nichtsdestotrotz fahren wir mit dem Programm fort und würde gerne meinen Kollegen Marius Nissenmüller übergeben. Und hier geht es um Using Generative AI to Promote Gender Equality in German Legislation. Und eigentlich ist das ganz gut, dass wir auf Deutsch wechseln, weil das ist ein typisch deutsches Thema, was wir jetzt gerade haben. Von daher, bitteschön.
Danke dir. Genau, mein Name ist Marius Nissenmüller. Wir hatten das Projekt gemeinsam mit dem Bundesministerium und haben uns mit der Fragestellung der Geschlechtergerechtigkeit in der Gesetzgebung geschafft und überlegt, wie man KI-Technologie einsetzen kann, um da eben das zu supporten. Da ist der Status quo ziemlich wichtig, wie Deutschland das Ganze macht mit Gleichstellung in der Gesetzgebung. Es gibt nämlich sogenannte Gesetzesfolgenabschätzungen, hier übersetzt als Regulatory Impact Assessments. Die sind verpflichtend, wenn man ein Gesetz schreibt, müssen die LegistInnen, das sind die, die quasi die Entwürfe schreiben in den Ministerien, solche gewissen Folgenabschätzungen machen. Das heißt, sie müssen schauen, okay, wenn mein Gesetz so umgesetzt wird, welche Folgen hat das auf gewisse Aspekte, zum Beispiel den Haushalt, Digitalisierung, Jugend, Nachhaltigkeit oder eben auch die Gleichstellung von Männern und Frauen. Das heißt, verstärkt mein Gesetz irgendwelche Probleme oder löst es die in der Gesellschaft? Das ist besonders wichtig, weil Gleichstellung von Männern und Frauen bei uns im Grundgesetz drin steht. Das heißt, es gibt Artikel 3, wo drin steht, der deutsche Staat soll darauf hinwirken, bestehende Ungleichheiten abzubauen und eben keine weiteren zu schaffen. Das heißt, es ist besonders wichtig, bei neuen Gesetzen zu schauen, okay, welche Auswirkungen gibt es hier? Und dafür haben die einzelnen Ministerien diese Checks entwickelt, so Leitfaden, wo man schauen muss, okay, welche Auswirkungen hat mein Gesetz, wenn das so durchkommen würde. Und Problem ist aber, dass dieser Gleichstellungscheck kaum angewendet wird. Das heißt, das Ministerium, das diesen Check betreut, beschwert sich darüber, dass viele Ministerien gar nicht machen. Das heißt, die gehen hin und machen entweder gar nicht oder sagen, okay, mein Gesetz hat gar keine Auswirkungen. Das heißt, die beenden diesen Check direkt mit Nein und haken das Thema für sich ab und sagen, nö, es geht hier irgendwie um Startup-Förderung, hat mit Männern und Frauen nichts zu tun. Problem ist aber, eigentlich ist der Check so weit gefasst, dass eigentlich alle ihn machen müssen. Weil diese Ungleichheit kann eben entstehen, wenn das Ziel nicht in der gleichen Weise für Männer und Frauen gilt oder Frauen und Männer nicht gleich profitieren oder Frauen und Männer anders davon betroffen sind. Und das kann halt einfach statistisch passieren, weil die Verteilung von Alleinerziehenden anders ist oder die Arbeitsverteilung, die Karriereentscheidungen, Führungspositionen, aber auch sowas wie Verkehrsteilnehmende. Es sind mehr Männer in Unfällen verwickelt als Frauen. Es gibt überall diese verschiedenen Auswirkungen. Das heißt, theoretisch sagen die Experten uns, es müssten viel mehr Menschen diesen Check machen, wenn sie dann ein Gesetz entwickeln. Wir haben uns dann das Ganze angeguckt und mit Legistinnen gesprochen und geschaut, okay, wie arbeiten die aktuell? Vielleicht ist es irgendwie eine Arbeitsform, die das Problem darstellt. Und aktuell ist es einfach sehr wenig digital. Die arbeiten mit Word, schicken sich Dateien per E-Mail hin und her, V1, V2, Final und arbeiten mit einem sehr, sehr schwierigen Word-Plugin namens eNorm. Das ist von der Idee ganz cool, weil es hilft einem mit so Strukturvorgaben, aber wirklich unterstützen ist es nicht und es ist halt auch super analog. Das heißt, da ist schon mal keine Möglichkeit, irgendwie groß anzusetzen und da will man auch gar nicht reingehen und gucken, wie kann man da irgendwas optimieren. Lohnt sich auch nicht, weil tatsächlich arbeiten an was Neuem, und zwar der E-Gesetzgebung. Das heißt, dieses Jahr oder nächstes Jahr wird das Projekt ausgerollt komplett, ist aktuell in einer Test-User-Group, ist eine Webplattform, wo kollaborativ dann Gesetze entwickelt werden können. Das heißt, da sind ein Editor drin und eben diese digitale Gesetzesfolgenabschätzung, wo man das Ganze wie so ein Online-Formular dann durcharbeiten kann. Und da gibt es auch schon Support und Hilfestellungen, aber aktuell wäre auch in der Plattform es nicht verpflichtend, das zu machen, obwohl es eigentlich verpflichtend ist. Das heißt, wir haben uns angeguckt, okay, wie kann man dann da vielleicht irgendwie ansetzen mit AI? Denn das Problem, warum diese Checks nicht gemacht werden, sind diese 3 Aspekte. Es ist zum einen ganz wichtig, es fehlt das Wissen. Das heißt, die Menschen, die Gesetze schreiben, mangeln den Kontext und die Relevanz über das Thema Gleichstellung. Weil die arbeiten vielleicht im Wirtschaftsministerium oder eben im Transportministerium und sind halt keine Experten für Gleichstellung, sollen sie auch nicht sein, die sollen Experten sein für ihre Domäne, müssen trotzdem aber diesen Check machen. Das heißt, ihnen fehlt einfach erstmal das Wissen, ist mein Gesetz hier relevant und wie wichtig ist es überhaupt, diesen Check zu machen. Gleichzeitig fehlt aber auch massiv Zeit, sich fortzubilden in der Richtung oder halt auch dann Zeit, diesen Check ausführlich zu tätigen, denn es dauert einfach immer mehr, immer länger. Es gibt immer mehr von diesen Gesetzesfolgenabschätzungen. Es kommen jedes Jahr neue dazu und auch von oben herab sollen Gesetze immer schneller entwickelt werden. Das heißt, die Zeit wird einfach immer weniger, die man hat, um so ein Gesetz zu schreiben. Das heißt, es sind mehrere Probleme, die dann am Ende des Tages diese Durchführung der Folgenabschätzung limitieren. Das heißt, auch da ist es keine Hilfe, diesen Check noch komplexer zu machen. Man muss eher gucken, okay, wie kann man bei dem Check supporten. Und da setzt unsere Lösung an oder unser Lösungsvorschlag, zu sagen, wir supporten eben bei diesem Wissenstransfer und der Entscheidungsfindung. Das heißt, wenn man diesen Check aufmacht, ist der erste Schritt diese Relevanzabschätzung. Ist mein Entwurf relevant für das Thema Gleichstellung von Männern und Frauen? Und hier wollen wir eben dann diese Entscheidung supporten oder challengen, indem wir den Entwurfstext des Gesetzes nehmen und in der AI geben und fragen, okay, hat dieser Gesetzentwurf eine Auswirkung auf Männer und Frauen? So, dann gibt das System eine Antwort. Wir nehmen die Antwort und sagen, okay, unser System vermutet, es gibt eine unterschiedliche Auswirkung. Das heißt, du musst diesen Check machen. Und unterstützen dich dabei schon mal in dieser ersten Einschätzung und erzeugen diese Awareness, okay, dein Entwurf geht vielleicht über Förderung von Startups, aber weil halt Männer und Frauen anders in Startups verteilt sind, ist es trotzdem relevant für dich, diesen Check zu machen. Und dann gehst du eben rein in diese Hauptfolgenabschätzung, das Main Assessment. Und da supporten wir ebenfalls mit der Kontexterkennung und Textgenerierung, indem wir Vorschläge erstellen, was Auswirkungen und Maßnahmen sein könnten. Da kommen wir gleich in einem Prototypen zu. Wir haben einen Low-Fidelity-Prototypen erstellt. Das heißt, das meinte René gerade schon, es ist ein Prototyp, der sehr schnell, sehr einfach, sehr günstig ist. Wir haben einfach nur Screenshots genommen von dieser E-Gesetzgebungsplattform und dann darauf unsere Vorschläge quasi embedded. Und da führe ich euch einmal durch, wie dann der Prozess aussehen könnte. So wäre dann der Texteditor in der Plattform. Das heißt, es ist ein ganz klassischer Editor. Man hat links so eine Kapitelvorschau und in der Mitte das gelbe und das lilane Post-it sind quasi unsere Prototypergänzungen. Das heißt, in der Mitte würde der Legist seinen Entwurf schreiben, das heißt Probleme und Ziele beschreiben und unser System würde erkennen, okay, aufgrund des Kontextes, den wir erkennen, könnten mögliche gleichstellungsrelevante Folgen auftreten. Weil zum Beispiel, hier sind wir bei dem Startup-Beispiel, es gründen mehr Männer als Frauen Startups. Das heißt, wenn du jetzt Startups förderst, musst du halt gucken, dass es irgendwie anpasst, weil sonst förderst du mehr Männer als Frauen. So. Das heißt, wir markieren die Stellen im Text und geben rechts eine kurze Begründung, warum das System zu dieser Einschätzung kommt und gehen dann weiter in die Folgenabschätzung, wo eben im ersten Schritt dieser Relevanzprüfung normalerweise die Option besteht, Ja oder Nein zu sagen. Wir würden in dem Fall, wenn das System da eine Auswirkung erkennt, sagen, nee, du musst jetzt in diese Hauptprüfung reingehen. Du kannst dich nicht wieder hier irgendwie rausargumentieren, sondern du musst dich einmal konkreter beschäftigen mit den Themen, geben dir eine kurze Begründung mit einem Zitat aus deinem Text. Das heißt, wir ziehen den Bezug zu deinem Entwurf, um dort eben zu sagen, okay, warum ist das System der Meinung, dass es da einen Bezug gibt? Und zwingen dich da sozusagen in diese Hauptprüfung rein, wo man am Anfang verschiedene Lebensbereiche sich anschauen muss. Das heißt, hier sehen wir den Lebensbereich Arbeit, wo man mit Checkboxen Bereiche auswählen soll, die relevant sind im Kontext des Gesetzes. Und hier würde das System eine Vorauswahl treffen. Das heißt, in dem Beispiel, Lebensbereich Arbeit, hat das System 2 Themen als relevant vorgeschlagen, die jetzt manuell geprüft werden müssen. And now I switch back to English. So in this assessment, the system proposes 2 things as relevant. So work and career chances. And you need to manually check them. So for example, you can open them and then you see a reasoning why the system thinks this aspect is relevant. You need to agree or disagree, and the system can learn from your decision. So if you disagree, the system can take that input for the next evaluation, and it also shows you a link to statistics why this checkbox is relevant. But of course, you can also check other things. It's not limited to the decisions from the system. You can also manually do other things. And then after you work through all these areas of life, you have to then formulate text about what possible impacts your law can have. And this is a perfect task for GenAI, because we can take the context of the law and then the checkboxes from the areas of life and then generate text, basically ask with a prompt what could be impacts in that areas of life with this law. But before you click that button, or actually when you click that button, you're first confronted with an alert. An alert telling you that now you have an AI tool which creates important texts, actually, because it's a law, and you as a legislator are finally responsible for the text. So basically creating this awareness of don't just wave through the result, check the text, read the text, correct the text, and then it's your product, it's your law. You can get more information, and then you have to basically agree that you accept this generation of text. And then you get an example AI output, what could be possible impacts of your law. You can correct that, edit it, just a text input basically, and then mark it as okay, checked and reviewed. And the same goes for the next page, where you have to formulate measurements. What measurements can mitigate these impacts? And again, you can generate a proposal, edit it. Here for the startup example, it says you can have a quota rule or financial subsidies for female-led startups, or mentoring programs, for example. And the last page is then the summary page, where again, the system takes the impact and the measurements and creates a summary. And it's for you to correct it, and in the end, review it and insert it into your draft, for example. And then we tested this prototype with legislators, and it was very interesting to see, because we had the discussion of whether the system should output continuous text or bullet points, because we feared that if we give them continuous text, they would not read it. They would just agree with it and then continue. So we had this discussion of maybe bullet points would be more simpler. But then the negative side would be, if we give them bullet points, they would need to invest more time and then formulate a continuous text. And some said, if you give me bullet points, I will just copy them into ChatGPT and ask them to give me a real text. So they would either way just use some system to do it. And then we decided to use continuous text, because legislators told us that they don't wave through text. It's their law. They sign it with their name. They wouldn't just use some AI output without properly reading it and accepting it. And that's why we decided to use this alert in the beginning with the accept button, that you basically are aware of the fact that it's your responsibility for the text. And the general feedback we also received that was the automatic specification is useful with the statistic links, and especially that seeing your text passages is a nice aspect. That during the system, you see citations of your law and examples of why your law is deemed relevant in the equality measurements. And with all the systems and all the ideas we developed, they are now focused on the equality check. But of course, they can be transferred to other impact assessments, because if the system can decide if it's relevant for equality, it can also decide if it's relevant for youth or sustainability. But overall, as I also mentioned, the time aspect, it's the legislative process in itself which also needs improvement. Because, as I said before, there are many gears you can turn to make the process more effective, and the impact assessments are only a small part of the entire process for creating laws. And yeah, that was all. Happy to hear questions.
The rising. We start here and then I come over.
You talked about this relevancy check. Did you also do evaluation on this check to like know how the LLM performs on this relevancy check, if it somehow assesses something as relevant which is not relevant, or vice versa?
Actually, all our examples in the prototype were already AI outputs. So the entire startup subsidy example we did with an AI, and we had interviews with people from the Ministry of Finance who were drafting a startup subsidy law and said, it's not relevant. I'm writing a law about subsidies. It's not relevant for men and women. And then there was a good example for the legislators think it's not relevant. And then we prompted the AI and it said, no, it is relevant because you have this different statistics of men and women. So in the first examples we did, we actually see this benefit that it's more on the expert side than the legislative side. And in the next steps, we would work with the Bundesstiftung Gleichstellung to give us more complicated examples where they say it's difficult for an AI system to make this decision. But this is the next step.
Okay, thank you.
Yeah, so in the second talk, basically, we talked about the kind of inherited biases in these AI models, right? And like, I don't know, how is this trained? Is this retrieval augmented generation, fine-tuning? Like, what is it?
In the beginning, it's ordinary models.
Okay.
So in the beginning, we're not adjusting any model. In the next step, we would use retrieval augmented generation to connect it with databases and statistics. Because right now, ChatGPT can't give you a source for information. And we're basically now trying to tiptoe to a good level of working prototype. So it could be that with normal models, it performs good enough. It could be that it needs the augmented generation. And after that, we might decide, okay, it needs a model of its own. It needs its own training. But right now, we can't make this decision because we are closing in on that topic.
Yeah, that's fair. Like, well, what I'm thinking is like, especially like for things like laws that kind of are relevant, right? Really for policy decisions and so on, right? Probably like, in my opinion, it requires like kind of a model where we know like what it was trained on. So basically with open source data and open source model and like the process where it's kind of open to kind of understand, okay, what might biases be, right? So because like, as you talked about, like the finance department said, okay, it's not relevant, right? The model said it is, right? But then now we're in the question, okay, like who's kind of right here, right? And there are basically biases in both, right? And like this, I think this is a cool tool and really good idea. Probably like, especially for that, like I feel like the things need to be at least verifiable in terms of what the biases could be.
I think this is an interesting use case for LLMs because of how they work and how they can see connections between topics, which maybe you can't see when you're not an expert in this domain. And in the end, it doesn't hurt because we're not influencing the law, we're influencing only the impact assessment, and we're also only trying to give them basically a push into the right direction. We also talked about formulating laws, and of course, that's something nobody wants. Nobody wants an AI to write your law. But helping in this field where you lack knowledge and you can't be an expert on equality, you can't train everyone to be an expert in this field for you to do this test once a year when you write a new law. Because that's how often you are confronted with this. So it's basically only trying to help you get the first steps in the field. And then they will probably do their own research. They will get this output and then try to educate themselves on the specific things it says. So I think this is a good field where a bias in the model is not such a big problem.
Okay, so we have a question from Dietrich, right?
Yes. Thank you very much for your talk. It's very interesting. And I want to know whether you think that your technology also apply for the big problem which is in the law science for many years already present. And as you know, we have too many laws, and some of them are contradictory because they are old and new laws are added without changing the old one, and so on and so on. Is it possible to apply your technology also to reduce the number of laws in total?
In the current state, not, but there was a topic brought up by legislators that they want a system that if they write a new law, that the system helps them detect existing laws which are conflicted or affected. And I think it's an interesting research topic, not in the scope of our project, but it's definitely a use case which needs to be solved in the future. Because as you said, it's getting more and more laws, and more than a legislator can overview. So these would be some system that can monitor all the existing laws and paragraphs.
Yeah, we have time for one last comment. If Dietrich is through.
Yeah, what I just want to add, like the core technology shouldn't really change, right? Like you're applying this in the context of basically you trying to detect in a legislative proposal, like, okay, if there are like gender biases and stuff, right? And then basically once you have this technology like at its core, right, you can also just analyze it. Okay, does this law say something or is contradictory to like another law, right? So it's like probably the same problem, but just with like a different twist, right?
I think this is where it gets complicated, because there you don't have the margin for error, I think. Because this is something where you would trust the system more, I guess. If the system says, no, I don't see any contradictions. And I'm not sure how good the current technology is with LLMs to overview all existing laws. And I mean, it's worth a try. But as I said, it's not the scope of the project right now.
Yeah.
Thank you.
So thanks again, Marius, for your contribution. And next, I would like to call our other colleague from the Fraunhofer IESE for her talk. Katharina Helten towards LLM augmented situation space analysis for the hazard and risk assessment of automotive systems. So we are changing the domain. I have a couple of clicks to perform. Also kind of usability test, but now it works. And the presenter is with you, so it should be working. So stage is yours.
Thank you. Yeah, hello from my side. My name is Katharina Helten. I work at Fraunhofer IESE, and my topic is LLM augmented situation space analysis for the hazard and risk assessment of automotive systems. It's a really long title. I hope afterwards you know what I mean. So first of all, motivation for our research interest. We are working in hazard and risk assessment. This is basically identifying potential risks in a driving scenario based on a hazard, which can occur, for example, brakes are not working, and based on a situation, for example, highway or rain or some different driving scenarios. The risk is then defined as likelihood of occurrence of this situation and the severity of a potential accident. In this example, we have the situation, we are driving on a highway and it's raining, and when our brakes are not working, our risk would be really high because the likelihood of occurrence of rain and highway is really high, and a potential accident would be really severe. So we could say, simplified, that our risk is really high. Now we want to define some safety goals or find some countermeasures for this risk, which this one is really obvious. We want to ensure that brake force can be applied. How can this be ensured? For example, we can have a second braking system using the handbrake, or go to a brake maintenance regularly, of course. Now more in detail, what are the tasks of a safety engineer? Because this is safety engineering. More in detail, again, we have the hazard, brakes are not working. We have the context, highway. And the first task of a safety engineer would be to find possible situations. So this is a creative task. I have to think which situations can occur. I can have highway and rain, highway and sun, highway and traffic jam, or whatever pops up in my mind. Then next I have to define these risk parameters for every situation that I found. These are severity, controllability, and exposure, meaning how severe is a possible accident. If I have an accident, is this situation controllable? For example, using the handbrake instead of my normal brake. And how often or how frequent is this situations? And these are the risk parameters which define the level of the risk. And in the end, again, I need to define a safety goal for this. So as you can see, this is really time consuming because I have to find in a complex driving scenario every possible situation which can lead to an accident. And this needs a lot of expert knowledge, a lot of creativity. I have to think about all possible stuff that can happen on the streets. And so our idea was, or our research interest was to use large language models to have a collaborative version between LLM and engineer to support the engineer and maybe save some time or even get better results. So as I mentioned, we have a time-consuming task which requires a lot of expert knowledge and creativity. And we have another big problem, which is completeness and correctness, because a safety engineer cannot ensure completeness because there are infinity number of situations. So maybe the LLM can help and find some specific situations which the safety engineer would not think of. So our solution is LLM and engineer collaboration tool. We don't just want to use LLMs, we want to make a collaboration to increase reliability and trustworthiness of the outputs. So yeah, the biggest challenge is reliability of AI outputs and the complexity of the context understanding. So our LLM has to understand this big driving context and driving scenario. So here's what I meant with collaboration. So first, the engineer has to load all context, inputs, hazards, and can start the tool. Then the LLM would propose relevant situations, for example, highway, rain, traffic jam, whatever. Then the engineer can do a relevancy check, like for your example, and say, okay, I reject this situation, it's irrelevant, or I approve. Then if we approve this situation, then the LLM can proceed and propose an assessment for the risk parameters. Then again, the engineer can review these outputs and say, okay, I want more details, give me some more reasoning or examples for your output. Or I want to edit this parameter, this is totally wrong, I have to change it. And in the end, you can approve if everything is fine. And then we are done and can proceed with the safety goals. So we have a strong focus on collaboration. This is our main idea because we want to increase this reliability of the outputs, because safety-related topics or driving-related topics are really critical, and we need a lot of trustworthiness and reliability in the outputs. So this is a mock-up of our tool. As you can see on the top, we can just store or load our inputs, our contexts, our hazards. We are using a safety box framework, which is our Fraunhofer safety box tool framework for doing a hazard and risk assessment. And we plan to integrate our LLM tool into this safety box framework. So then on the left side, you can see where we are. We already did highway, normal driving, overtake, and now we are at highway and traffic jam. Then in the middle, you can see the LLM outputs for this special situation and the assessment. And on the bottom, you can see some countermeasures. So this is just a simplified example. And again, strong focus on collaboration. The engineer can discard, approve, or ask for details after every step. And then in the end, a hazard and risk assessment is basically just a big Excel file. So we insert our LLM outputs in this Excel file and can then store it in safety box framework. So we did a case study to do evaluation on our performance. We did evaluation on an braking and accelerating system. So we have existing HARAS, hazard and risk assessment, for these systems, and we just compared these existing assessments to our LLM outputs. So this is just a simplified example of the prompt and the outputs. We ask the LLM to generate an assessment and gave the hazard, gave the context, and in the end, we got as output these risk parameters and a detailed reasoning, which is not shown here because there was not enough space on this slide. Yeah, just simplified. So for these exposure, severity, and controllability, the LLM always outputs a reasoning. Why is this parameter E3, for example? Then strong focus on collaboration. Engineer can edit, say, okay, every day, I think that this is wrong. The correct value is once a month. I approve. This one is good. Yes, this one is also good. Yeah. So what did we learn in the process? We basically learned that these this tool can simply save time. So our biggest issue is that doing a hazard and risk assessment is really time consuming. So we can save some engineering efforts, some time. But also this tool supports the engineer in understanding the driving scenario or these risks more in detail because the tool gives some specific situations which I did not think of, for example. And the tool also helps the tool gives reasoning for all of its decisions, and that's good for finding wrong outputs or inaccuracies in the assessments. The most important part was the context understanding. The LLM has to understand the driving scenario, and for this, our most important part was prompt engineering to give all inputs for the LLM to understand its context. Yeah. Right now, we are still working on this to integrate the tool into safety box, and we are also using retrieval augmented generation to insert driving statistics or some safety-related documents. Yes. Thank you for listening, and just feel free to give any questions.
I have a question. So, just very briefly, I think, so if you generate new cases and like you have a finished output, right? Did you try to, or is it, that's just what I'm wondering, did you try to use this as an in-context learning material for your next prompt? So after time, they would get more reliable results because it knows how it's supposed to look like? Or this is not part that you do not use your output to refine your model?
You mean so like storing a history?
Exactly,
and,
of the good ones, basically.
Yeah. We did not do this in this case study, but we are still working on it and want to improve our results. And for example, with this
Oh, yeah,
ideas.
okay. Okay, no, that's all I wanted to know. Thank you.
Any further questions? Yes, you have. Please.
This time I have a question. It's not moderating now. From somebody who's not in the automotive domain. You were talking about you can never have a full closure, right? You have a problem of infinite possibilities. At some point, when you use the LLM, you generate more and more and more scenarios. Do they somehow go to a big database that you can just have like a recommendation system in the end? So, I mean, in my view, many tasks might be very similar for the safety engineer. It's a matter of learning, a human learning thing. And you said that decision tree like highway braking, etc. Is it also a plan to say we make use of LLM right now to generate more and more scenarios, but later on we don't need the LLM anymore? It sounded to me like you don't really need LLM on the long run because you know everything at some point. You have a saturation.
No, because every time you do a hazard and risk assessment, your context changes because at some point you only do a hazard and risk assessment for a bus driving in Japan, for example, or for an automotive driving in Germany. So every time you do this risk assessment, your context changes because your context is also your automotive itself. So it can be a truck, a small car. It can you can identify risk for Germany, for one city, for the whole world, whatever. So every time you do this, you have this different situations which are relevant.
This is where the statistics come in. But you said you're feeding the system with statistics. Okay. Thank you.
Thank you very much for your presentation. My question is simple. Actually, my background is computer science, so we are also like focusing on generative AI. But I know a lot of domain nowadays working on, they are integrating LLM with their applications. But one question which come to my mind is why do you don't like use another state-of-art traditional technologies? I mean, what bring your idea to this that you have to use LLM for this one? Why can't you think that we should focus on state-of-art traditional technologies, like particularly like safety policy, because LLM using LLM for safety regulation and privacy aspects is very, how to say, is not yet granted to be utilized for some sensitive domain. Like, as you said, quality control, and these things are very sensitive. And if something happen, who will take responsibility?
Yeah, this is also what we ask ourselves in the beginning, if we or why do we want to use large language models? And the main aspect is the creativity point, because large language models are really good in being creative or being human-like creative, or even better in some tasks. And that's why we wanted to make a study on this. If an LLM can be as good as a human engineer regarding creativity in this time. Yeah.
For social good, it is using it as a supporting agency is very good. But if you use it as to replace human agency, I think that is like might take time to conform it. So like as a supporting agency, it's like somehow understandable, makes sense. But like using it like for as a human agency in some sensitive domain, like as my field is AI, to me, it's like we use it like to support the process. But like I'm not at that high level to integrate it as an agency, independent agency, to go ahead with some tasks. Like it might be like good, safe to say that supporting agency or co-agency, something like that, might be possible to use it, but like as an independent agency, because nobody will regulate it. Who will regulate it? The question is, if the machine regulate the machine, then that's like a little bit, I mean, early to say that. Like so maybe like the answer which you might try to find, that why you are going to LLM. There is a scalability problem with human, you cannot avoid bias, or the training problem, or another problem. Then it's easier for us to understand the using of LLM in your domain. So yeah, to justify these questions, why. So maybe you might need some time to consider that, why LLM in your field, because everyone using LLM nowadays in different field, right? So whenever I'm going, so like different domain using LLM, but for me as an AI engineer or AI researcher, actually, I think that LLM is that much powerful that everybody is going to integrate that with the society. If yes, I don't know. Actually, I cannot see that much independence within LLM.
Yeah.
Still, it is like it should be under control of humans, something like to provide as a supporting agency for human. This is my personal opinion, but I don't know, like if you use it in sensitive areas as an independent agency, but I don't think it might work.
Yeah, I also don't see it right now, maybe in a few years, but not for security or safety related things, because it is too critical. But our main goal was only to save some time, because the time an engineer needs to do a hazard and risk assessment is really expensive, and we want just to make it a little bit faster, this process. So yeah.
I would like to comment on that too. Like, my interest is in the structural similarities between language and music. So since we use transformer models, right, to generate music, we found, compared to traditional or other methods well established, that these create input, which is more natural in a way. It's more coherent. It's more varied. But I'm not talking about algorithmic production, which is super not usable for those tasks. But I can imagine that if you transfer this to a language, that I think particularly this technology would give you meaningful output that you can use, that is very close to language, has a coherent meaning. And I think, which might be another reason to advocate for transform models, would be that you can use much more of the data generated, as the quality in general, I think, is more better. Well, that's just a comment, I think.
Yeah.
Well.
Thank you.
If not, I would like to thank you again, Katharina. And we turn over to the next contribution, which is given by Felix, also from Fraunhofer FIT.
Exactly. Okay. Yeah. Hello. My name is Felix. I'm from the Data Privacy and Sovereignty Group of Fraunhofer FIT. And this talk is about how we can improve information retrieval systems powered by LLMs using data spaces and retrieval augmented generation. So at the start, I have this motivational example. So consider a query that's very domain specific and requires up-to-date knowledge. Like, for example, we want to ask like how many patients were admitted to the ICU due to COVID in hospitals in Tokyo and Osaka last month. So if we prompt this question to ChatGPT, which also now supports web-based searches, we get an answer that is not really satisfactory. And it specifically states, well, exact figures for each city are not consistently available. And we get some answer, but it's not really an answer. And what we would like to have is up-to-date information in here. And this AI models, the new ones like OpenAI, and they are also now really good at recognizing when they lack the specific information. But for other models, like for example, Llama here, these are trained on less data. They can also have something far more dangerous, which is pure misinformation and hallucination, where they just make up numbers, make a very convincing sounding answer, but it's actually not true at all. And this begs the question what we want, right? So what we kind of want is that we have a language model and it's actually connected to specific data sources. In our example, we would like it to be connected to the hospitals in Tokyo and Osaka. The language model can then source the documents there and then give us an answer, because language models are actually very good at analyzing text and extracting kinds of information from it. But as you might already think, okay, connecting a language model to really sensitive information is not really the best idea. So we would like to have an interface between that. And also the question is, okay, how do we actually get this data in the first place? Because like having like an interface that is actually connected to like hospitals and where we can actually source such data is an entire problem on itself. And the other question is, okay, how do we actually, when we have the context, how do we integrate it into the LLM? And with that, I want to give a little bit background on where we can actually source such data, because there is a concept already existing out there. And the concept is called data spaces. And for the people who don't know what the idea of data spaces is basically we want to connect data consumers to data providers. So we have a lot of data providers and a lot of people who want to get some data, but the connection between there is missing. And the data spaces try to bridge this gap by providing some functionalities that are provided by the federator. And it gives us some very important features like data brokering. So the data consumer consults the data space, and based on a keyword search, it provides some optional data providers. But it also gives us data sovereignty and some security and privacy features, as well as data interoperability and very important trust between those parties, because the actual data exchange is then directly between the data provider and data consumer. And these are large European efforts, and also including now Japan, where the International Data Spaces has now a hub in Japan, which means basically that companies of Japan can actually do data exchange with companies of Germany, because we have also a data hub, right? And one of a really big data space is, for example, Catena X, which actually is for automotive use cases. And I also want to give like a little bit of context, background on when we have data and how do we integrate this data into an LLM. And there are basically two approaches: fine-tuning and retrieval augmented generation. Fine-tuning is right, probably all of you know what it is, but we just add knowledge to the model, so we kind of retrain the language model, whereas in retrieval augmented generation, we add context to it. In the research here, we only focus on retrieval augmented generation, but a similar process can be done for fine-tuning as well. So what is retrieval augmented generation in short? So this is kind of the pipeline. So when you basically ask ChatGPT and it looks up a website on the internet, it augments basically the prompt using this technology. And what it first is doing is basically it rewrites the initial prompt to make it better interpretable by the LLM. And the second part is the data space, or the database, sorry, not data space, database, where the data is. We need to index it. And what this basically means is we need to transform all this data into right tokens, into like a numerical vector space, which makes it possible to really easily search this. And then we augment the data, augment the initial prompt with the data that we have found in the retrieval step, and prompt the LLM, and we get a response. Yeah, so this is basically just an overview of it. And now let's dive into the topic here a little bit deeper with this kind of representation. So what we have on the left side here, we have our data providers. This person here is the data consumer, and makes some very highly domain-specific prompt and forwards it to the RAG system, Retrieval Augmented Generation Framework, and it looks up data in the data space to be used and adds it then to the LLM, which gives us then a response. But the question is here, like, how do we actually integrate those technologies that are already established in the data space and in RAG? And it's kind of not directly obvious how to do this. And so I want to present you with two integration concepts here. We have three in the paper, but the first one is basically, well, we don't integrate it at all, right? We basically use it subsequent. But this has also some downsides, which is why we later on see how we can integrate these. So what we do here is we basically have a query that we want to ask to an LLM. But first off, the data consumer already knows kind of which specific domain it is about, what data basically is needed for this. And therefore, we use the data space functionality to simply retrieve some data stored in a local database and continue with the retrieval augmented generation pipeline. So basically, use the data space just to get data, right? Store it locally and apply it. But here's kind of the problem that that all the data is kind of centralized at the data consumer side. And some data providers, because of confidentiality reasons or other reasons, intellectual property reasons, is this not an option, right? So centralizing the data has here a disadvantage. Also, if the data is kind of sensitive here and the data provider has no control over which language model is used here, right? So for example, some companies have the policy, don't forward our data to OpenAI, right? So this is kind of prohibited. And so the data provider has no control over this LLM here. This brings us to the second integration concept, where we basically want to give the data provider a little bit more control over the RAG process. And this works as follows, kind of, or like an integration idea here, is that we data consumer rewrites basically the initial prompt and forwards it to the data space. And the data space has like component and prompt broker, which basically, based on this prompt, suggests some data providers. And the data here just remains on the data provider side. And for this, the data provider also has to index the data to facilitate the vectors-based search. So the data stays here, and the data space handles then kind of retrieval and selects the most important data in maybe distributed protocol. And then we forward the matches to the data consumer, which then can augment it and send it to the LLM. So in this integration concept, the LLM here is still not in the kind of control scope of the data provider, but we gave the data provider more control of its own data and only forwards the really necessary data and not really builds up a large database on the data consumer side. So this is an advantage, and like this third integration concept, which I'm not going to present, it gives basically the data provider also control over the LLM here and also about these two components, which then increases the control of the data provider even more. And so we have multiple options here how this could work, and all could be basically implemented together, which gives the data provider and data consumer a choice of what they need based on their use cases. Yeah, so and these are some comparisons. I talked about most of them. Maybe one noteworthy here is a con for the second integration concept when we actually use the data space, that we have some data space latencies. And we don't know what these are yet. But this brings me to my last slide here, and potential outlook and future work. Is actually using one data space to implement one of these integration concepts, for example, the energy or mobility data space that are well established, and then investigate certain issues like the latency here. And also for very confidential data, privacy and security issues are very relevant and need to be investigated as well. So the data space supports and gives you some data sovereignty options, but they might not be enough, and additional ones needed to be added. Yeah, and this brings me to the last sentence. So if you take anything away here from this presentation, is that data spaces are basically next generation data marketplaces between like distributed entities, and could really provide a great interface for domain-specific question answering systems that LLMs right now cannot handle because they're simply lacking the context. Yeah, thank you very much for your attention, and if you have any questions.
So, time for questions.
Thank you very much for the presentation. As you know, with the introduction of LLM chatbots, our social network not remain only social. So there is not only social contributions, but there are a lot of machine-generated content. So in that case, how these data spaces ensure the quality of data when they sell it to the consumers? How we can ensure that this data has the quality? I mean, it is human touch quality.
Yeah, this is a very good question, and it boils basically all down to kind of this trust between the parties. That kind of a data space, like not everybody can directly join. So there are different kind of data spaces. There are closed ones, there are open ones, and really the data space itself wants to provide this kind of assurance that kind of there's not data that's basically useless, right, and fake or generated, because the data space is also a little bit more than that. You can also have contractual agreements, and in kind of these contracts that are here negotiated between data provider and data consumer, you can set certain rules. For example, okay, I don't want any data generated by AI in the data that you provide me, right? And this is a great advantage of actually using data spaces, because you can kind of soft enforce these data utility requirements for you. If that answers your question.
you know, for example, a lot of companies, they destroying, demolishing their factories, and instead they're making these infrastructures. But the question is that, you know, there's a, for example, the how these data, you know, they collect, and then how the life cycle of these data are not really, you know, really trustworthy, something like that. For example, with introduction of sophisticated technologies, so like the quality always, like data quality will be the next, I think, emerging business within these spaces. And I think that the more focus on the, like, which technology should be utilized to ensure the data boundary and the human touch within these boundaries. For example, there are a lot of interferences of machine intelligence within these data, and without having a clear roadmap to ensure the safety and the security and privacy and overall the quality of data, having these technologies might be one-side profit, I think, which is the producer and the businesses, where the consumer might be on the risk side if we don't have such sophisticated technology to ensure that there should be a trustworthy on the data, right? Because this is a question which always like comes from the government side, that towards these businesses, that they're running this type of business like without ensuring that that technology I think is we don't have it right now. In Japan, actually, they are focusing on this, like how to make that technology right now. For example, it's easier to have those data like look like human touch data, right? So I think maybe it might be a future direction, I think.
So these data spaces already exist. And well, it's true that it's still like a future direction, but kind of like, if I heard like a question, kind of you still like not convinced that the data that these data spaces provide is kind of trustworthy. Is that kind of your argument? That you say, okay, these are kind of controlled by governments or anything, that's and too much AI is in these data spaces, so the data that these data spaces provide is not trustworthy? Is that your question?
Always like have a question like that. For example, like looking gray to these business models, like they say, like usually, like for example, in Japan, like they're focusing much because this is demand right now, these things. But you know, of course, I understand Japan is very conservative; they not compromise the quality. But I do believe there's another counterpart businesses which they try to misuse these strategies, and then they will establish something like that themselves and appeal themselves that they're like. Of course, there are always like a question that which technology you're going to use to ensure the quality of data within these data sets spaces. So and then the yeah.
Maybe we get one last comment here, because otherwise we're running out of time. We have one last presentation. I would recommend postponing that to the coffee break. Quick one.
Yes, I was just asking myself if you know any existing frameworks to use these data spaces. I don't know.
Frameworks, you mean like implementations
Yeah.
already? Yeah, there are some. So basically here we have these two, like Gaia X and IDS, like two. Have you ever heard of IDS in Fraunhofer?
No.
It's actually a big thing in Fraunhofer, I think. So, and also like in your specific department. Yeah, not big enough, I guess. So yeah, so there are existing implementation of this. For example, this has the IDS connector. There's like an Eclipse data space connector. There are already a number, like I'm aware of, like we did like some survey, like a list. There are over 50 different data spaces for different domains established. Given, okay, like not every one of these like is really highly sophisticated and still in its kind of initial steps, I would say. But there's usable software. And also here, like EJEA is a really big European-funded project from Germany and France mostly, but all over the world, to be honest. And they have existing implementations and frameworks. And yeah, you could like Google these two and find like a lot of resources.
And which one would you recommend? So did you try them or just?
Yeah, I've personally worked on this on top here, and yeah, also BOSS, to be honest. I would go for this one. Okay. Check it out, and maybe the Eclipse Dataspace Connector, which is also, to be given, it's also still in development and so on, but it's like it can be used. And also Catena X, for example, for you specifically, right? This is for the autonomous use case, automotive network. And I think like they probably will be interested in like what you can provide. Yeah.
Yeah. Thank you.
Thank you very much, Felix, for your contribution. And maybe later on in the coffee break, we can discuss further. So now it's my pleasure to introduce the final contribution for this afternoon. Maria Zangel from Austria is with us. Maria, can you hear us? Everything okay?
Yeah, everything's fine. Thank you very much.
Okay. So you are going to introduce the Ithaka project, as I've seen on your slide.
Exactly. So good afternoon, everyone. My name is Maria Zangel, and I'm the PhD student of Professor Dietrich Albert at the University of Graz. And matching the workshop, please. I would just say, if you have to click on the slide. So matching the workshop topic of data sovereignty and generative AI, I have the honor to present to you my dissertation plans and some work we have done so far in our project. The general title of my dissertation thesis will be Empowering Citizens for AI, Assessing Public's Misconceptions about Large Language Models. So I asked ChatGPT a question about quantum mechanics, and it was replying so fast, it must have a very deep understanding about physics, right? More than 100 million people use ChatGPT, but how informed is the broader public actually about such tools? What misconceptions do they have, and what knowledge is actually needed to use such tools in a beneficial way to them and to others? And to answer these questions, we need to assess their misconceptions and provide them with knowledge tailored to their current conceptions in order to empower citizens for the AI era. So next slide, please. The project I'm doing the PhD in is a EU project called Ithaka, Artificial Intelligence Enhanced Civic Participation. And the main objectives of Ithaka are the development and test of an online platform for civic engagement. And we will test it in 2 pilot cities that have a rather low voter turnout at elections. So we will develop a platform for local municipalities to engage with their citizens and citizens being able to participate in local political decision making. And this platform is going to have integrated AI tools, and the unique selling point, because there are a few platforms already that are doing exactly that thing, but the unique selling point of Ithaka is to focus on vulnerable group members, for example, the elderly or less educated citizens or citizens with disabilities. So the platform should facilitate the engagement of these often marginalized groups. Next slide, please. And that was the impulse for my research, because members from socially vulnerable groups, as I said before, the elderly or disabled citizens, are underrepresented in political participation already. Vulnerable individuals are also more likely to be disadvantaged under the influence of AI-based decision-making, so what we know is bias or unfairness in AI. Additionally, they are less involved in user studies for technical design, so for usability studies, for example. And so their needs are mostly disregarded, and that leads only to greater vulnerability in this context. So why should we integrate AI into civic engagement? Well, certain AI systems have the potential to increase inclusivity, as they can simplify language or translate language. However, in order to meet the needs of vulnerable group members, we need to ask them what could be beneficial and what would facilitate civic engagement for them. Next slide, please. However, if we want to empower citizens with large language models, they need to have some knowledge about these models, because interacting with them with flawed conceptions about generative AI bears risks for inappropriate use or over-reliance or under-reliance on these models, or privacy risks, for example. So we need to know what is the understanding about LLMs that the public has, and the few existing measurements we have right now are based on self-assessment. Self-assessed knowledge can significantly differ from actual knowledge, and it will also not detect misconceptions, and experts assume that the public has a lot of misconceptions about AI or generative AI due to its complexity and novelty. So we need an objective assessment of knowledge and misconceptions about large language models that is appropriate for the broader public, meaning that it's not too complex and that it's gathers conceptions that are necessary for safe and appropriate use, or not like questions when who invented the first machine learning algorithms or something like that. So next slide, please. I have planned 3 studies to explore what I just mentioned. So in the first study, which we've already conducted, we explored technical requirements of different stakeholder groups, including citizens from vulnerable groups, for civic participation. So what features and functions, mainly AI features, but also classical IT features, would the different stakeholder groups like to have on a civic engagement platform? And for those outcomes, so for the desired functions that we gathered in the requirement analysis, we investigated what individual knowledge is needed to use the tools safely and appropriately. And in the second study, I want to identify what misconceptions or correct conceptions citizens, so meaning the broader public, actually have about the tools they wish to have. And in a third study, based on that, I want to investigate if the knowledge and the misconceptions about large language models have underlying prerequisite relations that would then enable the conceptualization of an adaptive assessment. So on the next slide, I show you the context of the first study, where we developed a technical requirement questionnaire. This technical requirement questionnaire contained a list of several functions or features on the future platforms, such as language simplification, topic recommendations, and so on. And this questionnaire was given to citizens from vulnerable groups, as well to municipality employees and municipality decision makers. And in focus groups, we discussed also with municipality managers what AI tools could benefit and support them in gathering citizens' opinions. And after we gathered those technical requirements, we discussed in 2 focus groups with AI experts from different fields what the individual knowledge is that is needed for the safe and appropriate use of the required tools. And on the next slide, I'll show you the outcomes of the technical requirement questionnaire. So the highly desired applications were those that are reflected in the functions of ChatGPT. For example, the language simplification or the chatbot for interactions. And this is why I will use ChatGPT as a use case for my following studies, which I will show you in the next slide. So in study 2, I will first explore the knowledge and misconceptions about ChatGPT through semi-structured interviews. I will then compare the actual misconceptions of the participants with the experts' assumptions from literature and also from those gathered in study 1. Next slide, please. And I will do interviews in a one-to-one setting with about 10 to 20 or better more citizens who have at least heard of ChatGPT but have not received proper education about it or about generative AI in general. And the interview data will be analyzed qualitatively by forming categories of correct and incorrect conceptions and assigning statements to those categories. And from that, I expect to get a list of correct and incorrect conceptions of ChatGPT. And I show you on the next slide an example of my planned approach. So from the answers or statements in the interviews, we can infer certain underlying conceptions a person has. So, for example, if one says that ChatGPT has a deep understanding about the topics it's trained with, we can infer that this person knows that ChatGPT is trained on data, but we can also infer the misconception that ChatGPT has a deep understanding about it. It's in the human sense. So how can this extracted list of misconceptions and correct conceptions be used to conceptualize an instrument for adaptive assessment? Next slide, please. The next step would be to identify a theoretical concept structure of misconceptions. And the knowledge space theory and its extensions enable formal foundation modeling through prerequisite relations of the knowledge components. And on the next slide, I will show you an example of how that could look like. For example, if a person knows that there are biases in training data, so on the right side, on the left, on the right side in the middle, we can infer that this person also knows that ChatGPT is trained on data. So this is a prerequisite. And also the prerequisite to know that ChatGPT will not automatically inform one about its limitations. So the on the bubble in the middle at the bottom, one should have the correct conception that ChatGPT has no true understanding about its own knowledge. So this would be a theoretical concept structure. Next slide, please. So after I have identified such a theoretical concept structure, I need to construct items. So I will create a questionnaire by item construction that can then empirically assess the identified conceptions and misconceptions about activity. And the third step is to validate the theoretical knowledge structure we have constructed in the first step with the empirical data. Therefore, I expect that items that are assumed to be more complex, as they have more prerequisites, are solved less frequently than those with less prerequisites, which are assumed to be less complex. So I will test if the theoretical concept structure does match the actual relations between public conceptions assessed through the questionnaire. Next slide, please. Yeah, the third study, especially the first step of identifying a prerequisite relation structure, which is usually done manually by hand, is very resource intensive and time consuming, as this is usually done by asking experts or teachers. And first, a still open question in my plan or in my research is if, to what extent or where I could make use of machine learning to identify a theoretical concept structure. And there are some publications that some innovative methods have already outperformed the traditional ones. However, I'm at the early stage of researching, and I've also no background in computer science or machine learning, so my background is psychology. So I'm not sure whether this is doable or if it wouldn't be a own dissertation topic in itself. But on the last slide, I will also acknowledge or mention two key challenges. And the first are the uncertainties in the exact mechanisms of large language models. So even for experts, and this should not be a reason to not teach the public about AI. But we should rather communicate the uncertainties of LLMs to citizens, especially that the inner working is often intransparent and unpredictable. And the second challenge is that the models develop very fast, and they are getting better, and limitations reduce or change. And the knowledge assessment I want to create should be sustainable to such changes. So I would rather like to focus on the basic mechanisms, for example, the huge amount of data that is needed to train such models. So I would rather like to focus on that and not so much on limitations or strengths of the models. So yeah, that was it. Thank you for your attention. And let's get in touch if you're interested in what we have planned or just want to exchange a little bit.
Thank you very much, Maria. Yes, there was some clapping as an echo. I was a bit confused. Yes, one more question from...
Yes, thank you so much for your presentation. Could you show us again the open question that you stated regarding machine learning, please? Thank you. Yeah, this one. One further. Yes, that one. Well, I'm not either a computer scientist or musicologist, but with my limited knowledge, wouldn't it be able to annotate a data set used to then not retrain but fine-tune existing language model to predict labels on a new text data set to identify these as a theoretical concept structure? Please ask the colleagues here, maybe they can help. But I think that wouldn't that be like a probable concept to do?
So the question was to me or to the colleagues? Unfortunately, I don't see the room, so.
That's really a bad situation. You don't see anyone here in the room except for the one who's standing here right in front of the camera. But I think the question goes to the room. If there's anyone able to help you finding answers to your open questions and to give you background in the other field of I don't know, informatics or yes. So the question goes to the room, to the real room. Maybe René, you can help.
Oh, the room is answering. No, just a question back, to be honest. It's like, for example, the second one, knowledge graph construction using key phrases, etc. I would like to forward this request or your idea to the chair of computer science at Aachen University, because they are dealing with these. And maybe it's okay if I may take your presentation and just forward it to this group of researchers, because they want to enhance the LLM with knowledge, so to say. That's what I have at least understood from their work. And second, if I may also forward this to a colleague of mine when it comes to the part where you say it's about inclusiveness. I would really like to get you guys in touch. Marius already knows what I'm referring to. Yes. Is that fine?
Yeah, thank you, of course.
I don't have answers, I just have questions back, so what I can do my best. But there's another comment, right?
So I know this second one, this knowledge graph construction. So basically, you just to understand the setting again, like you have data and you want to build a knowledge graph out of it. Or what was this again? Because like this seems to me that you want to use knowledge graph embeddings and then query embeddings. If that is something you can look up. Basically, query embeddings generated by knowledge graph embedding approaches. And then you can basically use key phrases that are also kind of embedded, right? And perform like a similarity search for extraction.
Okay.
That's kind of how our knowledge graph kind of works in a way, at least using AI. There are, of course, also like some graph-based algorithms, right, that just do graph traversal stuff. I know when you basically have knowledge graph, you encode it to embedding spaces and then use similarity searches. And that you can basically also encode kind of sentences, right? And perform similarity search in that direction. I don't know if this helps or not.
Yeah, but it sounds like a good idea with the similarity search, because a lot of applications about the prerequisite relations use Wikipedia pages, and those have all the links. So I don't have the huge database they are using. So
are you aware of the Wikidata knowledge graph? There's like
no.
basically Wikipedia was kind of mapped to a knowledge graph, and it's called Wikidata.
Okay. Okay, I will check it out.
Maybe not all.
No, but I want to say it all seems that you guys need to talk again. I would also put you guys in touch, because I have all the contact data, and then Maria can ask back to Felix, because I for some reason forgot that he also belongs to the group I was recommending. So sorry, it's getting late today. Okay. Anything else? Any comments? Maria, are you fine? I'm looking at the screen, but need to look there to the camera.
Yeah,
okay.
I'm fine. Thank you.
Yes, also again, thank you very much for your contribution. I would say we are just on time. It's amazing that we really caught up all the lags that we had this morning. I would say thank you very much to the visitors, to the audience for being here with us, also remotely, to being with us such a long time, which is really exhausting sitting in front of the screen all the time. Thanks for the speed. Pardon? Yeah. But no, I think especially you don't know. But for video conferencing, I mean, I need to be specific. I know, sorry, it's computer science. Then again, thank you for the authors, for all your contributions, for your presentations, for the vivid discussion we had in this group. It's not question. Sometimes you have to make up some questions because to get the conversation running, but it's not necessary. So once again, thank you very, very much. And maybe some final words from Dietrich and Sabine.
Yes, Dietrich, please.
Yes, I think this was a really great workshop, and I hope very much that at least all the slides can be made public so that some of these good ideas the audience or some of us may rephrase or maybe reanalyze and so on. In any case, I hope very much that we can continue this great type of workshop and very soon with both of the organizations and GRANITE and EJEA. And thanks to all the organizers and especially to René and Sabine, and of course to all the presenters. I was really impressed by the quality of all the presentations. Many thanks again.
Yeah, thank you very much, Dietrich. And I also hope to see you soon again, and maybe already in November when we have the next EJEA annual conference, hybrid style in Sweden. I would like to forward you the information again by email, and the call for contribution is still open, even though it's announced that it is closed by September, but it's extended until the middle of October, and we are looking forward to your contributions. I think many of the presentations we have heard today would also fit into the format of our conference in Sweden. Thank you very much. It was our pleasure, and I'm looking forward to see you tonight at the socializing event, and maybe tomorrow or the day after tomorrow here at the conference site. Thank you and goodbye.
Enjoy your afternoon. Goodbye. Goodbye to Austria.
Thank you very much. Bye.